All right, welcome to day 30. I am almost one solid month in on 365 days of code, so I'm excited about that. Um, Honestly, I've been literally working on freaking taxes like all afternoon. Um, and just in general, it's been a interesting month. I mean, it's been very good. It's been very productive, but also, I have my own personal challenges going on. So, this morning, normally I would have sat in on class at lunchtime, and I would have streamed during that time frame too. But just because I had a lot going on, I really needed like a mental break, a little bit of space, and that's what I did. I took some space. Actually worked on a random project. I had got like these tabs for my Bible like a while ago. Somebody had gifted them to me, and then I never really sat down and put them in. So I just kind of, I spent some time in like, I guess, prayer and like reflection and working on my Bible, like kind of organizing it. And that was pretty much it. Took me honestly like, I want to say it took me more than 2 hours to put those tabs in, only because I wanted them to be like neat and organized and everything for my study Bible. But anyways, I kind of enjoyed that. This morning I was like really conscious of like not wanting to overdo it and wanting to give myself space, like I said. So I pretty much did that, and I'm glad that I did because I think that I feel more um, I feel more rested, I guess you could say, mentally, even though it's almost midnight. But and I did have a long day, but I think, I've been trying to, like I said, the biggest thing for me is sustainability. This whole challenge is all about sustainability. So I can't, I really don't want to overdo it. And especially this early on in the year, I really don't want to overdo it when it comes to the goals that I have and being able to sustain the pace that I'm on for the entire 2024 and ultimately beyond. Because some of the goals that I'm starting or some of the new endeavors that I'm getting into um, this year are definitely things that's going to be going for maybe the next decade or so. Who knows? Maybe even longer. So, um, yes, sustainability. I'm gonna keep talking about it because, like I have said multiple times, I am the burnout queen. I have been the burnout queen. I'm trying to retire my title, and it's way more challenging than you might think because I'm like a go-getter, like busybody, always been like a overachiever, and I think there's a time and a place for that. But yeah, yeah, yeah. So, anyways, I feel good though. And then I spent like literally the entire afternoon doing my taxes. Well, not really doing my taxes, but just getting all my documents prepared for someone else to do my taxes. Because yeah, that's a whole thing in and of itself. So I feel good about that too. I was able to get everything organized that I had to get organized, get all my expenses like itemized and everything. So yeah, that was fun. But it's good because taxes is usually something I dread, especially if you like with me, I do like a lot of contracting, and actually in the past, like last year, would be more so me getting back into the entrepreneurship space and being a multipreneur. It's like I'm waiting for all types of different companies to send me tax forms, and then I have to itemize all my expenses, and it's a lot of stuff that you have to do versus being a W 2 employee and you probably already paid your taxes. And then, when you have a business, you want to make sure you get some write offs and stuff like that. So, anyways, yeah, I spent like, I've been doing that since 3 o'clock and it's almost midnight. I literally just got done. I technically have like 5 more receipts I have to upload, but for the most part, I got everything done that I needed to get done. So I'm glad that was like a band aid, like I had to rip off. So, anyways, now it's time to get at least I really want to get some studying in tonight. I have I didn't sit in on class earlier today, so I was like, that's okay. They record the classes. Um, Today, I'm probably, because it's already midnight, I'm probably just going to listen to the material from today, do my best to possibly follow along, depending on what labs they give us, because they usually don't show us which labs are available until the week opens. So since this was the first session of the week, I'll see if they gave us labs or if they just gave us collab notebooks like they did last week. But either way, I am excited about this material because I've been wanting to learn about vector databases for a minute. It's been something that's very talked about with the AI space, and I really just have not have had any experience with it. So this is a good opportunity, I think. So I'm going to be watching that course. And possibly pulling up some notebooks and things like that in the process. So I will probably share my screen if anybody is interested and wants to follow along with the material. But yeah, thanks for listening to my my opening spiel. Thank you for dropping in, Fizzy. Coding with strangers. Oh, okay, that's cool. Um, Trying to build a main page for my Valentine's game. That's cool. Get some work in then. And Mirza's here as well. So yeah, we're just gonna chill and vibe and get some work done. Um, I feel like it looks really cute. This looks really cute right now. I don't know. It's like this every time, but for some reason it looks cuter today. And I accidentally left my coat hanging up, so just ignore that. Just act like it's not even there. But yeah, I'm feeling pretty good. Honestly, oh shoot, ad break. Anyways, oh, let me make sure I open up Chrome. Let me make sure I open up. What the heck, bro? I thought I closed everything. I didn't do. I think I really still want to do this one. See, I want to leave this open. Why was I opening? Oh yeah. I say I'm doing good, but my brain is a little fried. I can't even lie. I want to make sure I can see YouTube chats. Switch account. No. Oh my god, what am I doing? Studio. YouTube Studio. I need to set some type of automation that like opens everything that I need. I'm pretty sure I should be able to do that from like a terminal script. Shorts live. Okay. We have to make sure. Let's go full screen on that one, and then split screen these, I guess. Oh, and then I just immediately got hungry. I do have food like right here immediately available, but Cyber, oh my goodness, welcome in. You said you're new to cyber. I'm not working on anything cyber related today. I'm working on AI, but I am actually working on a cybersecurity certification as a secondary thing. So that is something I'm new to in that regard. But today I'm going to be catching up on my Gen AI course. The one that I'm doing is Google cybersecurity on Coursera. So I'm trying to use that. I want to finish that certificate and then see if I can pass the certification. I think it's a CompTIA. I'm not really fully versed on. all the security plus. Okay, yes. Thank you. I was gonna say I'm not really fully versed on all of the possible cert options, so I want to say that sounds about right. Here, I'm about to pull it up actually. Can you tell I really was? I'm not lying about doing freaking taxes all afternoon. I was literally, I made a whole spreadsheet. I really like organized it. So, um, can I write off my desk footrest? The questions we have to ask Google. Let's see. If you go to Coursera. No, I'm not looking to work in the cyber field. I'm looking to expand my breadth of knowledge as I am growing into like startup CTO territory, and I have no real foundation in cybersecurity. So I think that's a big, big, big gap in my part. I don't really expect to be an expert, but I do believe that I should at least know the foundations and be able to eventually engage somebody else to be able to come into that type of role. And it's very little that you can do to vet somebody's skills when you don't even know anything about the technology. So that's really where my motivation is coming from. Actually, my biggest work on my long-term goal right now technically is getting into AI research. So you will see me, like I said, this cert that I want to do here is really more so secondary right now, but it's something I do want to get done. But my primary focus is AI. So I'm getting ready to go back to school because I want to get a PhD in machine learning. So that's just like that's gonna be like it's gonna be like probably 7 years. The masters will take a solid 6 to 7 years. Yeah, that sounds about right. Yeah, AI research is revolutionary. AI is just it's such a big field still, even though obviously it's gotten really popular in recent months and years. The research side is just, we still just barely scratching the surface, honestly, because we're still branching out from decades old research. So it's just so exciting to me. I've really been following and trying to dabble in it since about 2017, I want to say. I took my first course probably around 2017, but at that time I was still pretty fresh in my career because that was the same year at that time I was in my first full stack like software engineering role. So it was a lot to try to take that in and still be gaining like a lot of my foundations. But now I have finally given I have finally given up the full-time SWE roles in an attempt to actually get on the path I want to be on, because even in the last team that I worked on, I had really hoped that it would evolve into opportunities to do more AI machine learning type of work. But funny thing is, even though the company also thought that that's the path they were going to go in, they found out they had to actually build a stable platform and modernize some work in the industry that they were doing before they could even touch the surface of data or machine learning. So it was cool. I really enjoyed that company, but it was like Y'all are really, it was wrecking my brain trying to be like a Java, um, do Java microservices and IoT stuff like during the day, and then trying to learn Python and work on Python and machine learning projects and stuff by night. That was just not, that wasn't the, it wasn't the business. Let me just let you know. But this is the one I was talking about. Google. Google Google Cybersecurity Professional Certificate. This is the one that I am working on. Actually, I need to. I was debating on seeing if I can get. I want to apply for some financial aid on this course. So that's the reason why it says I'm not enrolled anymore. I had to unenroll just to do this. But yeah, this one prepares you for. So I actually already did the first module of this course. Depending on how I feel, I might just re-enroll and pay. I think instead of enrolling, I had enrolled in the course or in the certificate. I need to, if I'm gonna pay for it, I need to be on the Coursera membership, because this Coursera membership is like $59 a month, and the certificate membership is $49 a month. So if I go to Coursera Plus, then I obviously that will open up plenty more things I can actually work on Coursera besides just this one certificate. So I'm going to re-enroll. But yeah, this is the one. And dang it, I can't remember. Oh wait, let me see. Oh yeah, CompTIA Security Plus. Okay, so can confirm. Another thing about cybersecurity is that surprisingly enough, I guess it's not surprising, machine learning, large language models have like a lot of security risks right now. So that's interesting to learn about too. PhD is not easy, of course. Takes as long as it takes as long as what you want to do. That's not true. The type of program I want to get into, I would definitely be capped. If that's what you mean, I would not be able to take my time. They have a timeline requirement on how long I can take, how much leisure I can take. Want to get into cybersecurity because of the rise of AI. I truly believe we are the most vulnerable now. Rookies will be able to create insane malware and use it with AI. Yeah, possibly. But also, I mean, I agree that there is a big gap in security due to, some of the more recent AI tools, but also like the idea that people can just like create stuff just because AI can code for you. Like, you still gotta know what you're doing. But that's just my thing on AI coding in general. I am loafing on this cybersec thing. Doesn't making malware require digging around to find new exploits? Because widely known exploits usually get patched. Yeah, I think it's interesting that I think we give machine learning more credit in certain areas and less credit in the areas where it probably really matters the most. Like, I'm less concerned that a person who doesn't know how to code is going to be able to just go out and make malware. I'm more concerned that the people who don't understand that LLMs can hallucinate and literally make up like a LLM can literally make up a package, like a say you ask for a code sample, right? A LLM can make up a fake package that doesn't even exist and say, hey, you should import this into your code. And if you don't know any better, you literally just copy and paste that code. And then someone who has already anticipated this actually makes a malicious package, and you download malicious packages. That's actually a thing, and that's actually something that a lot of people don't even think about. Um, and even if it's not a made up package name, it could be a software package that doesn't exist anymore. It used to exist and now it doesn't exist anymore. So the LLM could recommend this package that actually doesn't exist anymore. But again, it's still the same. It's still the same idea. On the proactive side, some malicious actors already went out and republished a package under that name, which is way easier to figure out. Like what packages would have been recommended 3 years ago but don't exist anymore. Yeah, and then you just got people randomly downloading shit into their code. They don't even know where it's coming from. And that's a whole thing. I read a paper about that. No, I read an article about that. I think I posted one. I don't remember, Preacher, if you remember, because I think I posted about that before. I know if I didn't, that was a terrible thing for me to skip out. We might have that one in the channel. Got you a surprise. What is this? Okay, hold on. I gotta stay focused. Where am I? Let's do this cloud on air. By the way, this is the sessions that I'm attending right now. Startup School with GenAI. So this is definitely more so geared towards practical use cases, how generative AI can be incorporated into different business opportunities, whether it's internal or whether it's making products. And it is geared towards technical team members. It's more so geared towards developers, product managers, and CTOs. So I recommend this if you're interested, if you're more so looking at the practical side of, Gen AI, maybe incorporating it into a company, or you have a startup idea. And Google Cloud has plenty of tools. If you didn't know, Google's research is really what has brought this new AI boom. Their paper from back in 2017, I think. Attention is all you need. That's like the foundation for all the LLMs that are out here right now. So can't go wrong. Google does good work in the research space for machine learning, contrary to what people might think, because ChatGPT definitely they got beat to the market on like a widespread tool. Yes, but AI makes doing things easier. I am a rookie still, don't quote me. Yeah, I'm glad you brought the topic of the rookie thing up, Cyber, because it's no no shade to you or anything like that. It's just a very interesting topic in general. To me, it's a misconception that, essentially, yes, AI can code for you, but like we didn't need AI to code for us. Like newbies never needed AI to code for them necessarily, because before people had AI coding for them, they just copied and pasted from Stack Overflow. Like it's the same thing ultimately, because if you don't know what you're doing with it, then you're still at a loss. You know what I mean? And a lot of times when you get code from LLMs, that code is not necessarily functional. Just like when you copy and paste from Stack Overflow, that code is not necessarily functional. And that's actually the primary reason why I don't really recommend, because I teach in coding boot camps and stuff. So I don't really recommend I don't recommend stuff like ChatGPT to my students, because it's like you don't even have the knowledge set to even process whether the code you're looking at is legit or not. and it still can cause you more harm than good. So I do believe it's good as a troubleshooting tool. It's definitely helpful, but yeah, it's more so is I think it's even is I don't know. It's just interesting because it's like, yeah, because people are like, oh well, people will cheat on interviews and stuff, and it's like you're not gonna cheat on an interview because because when you interview for a company, I'm not gonna let you have ChatGPT open. So like, why is that even? You know what I mean? But I get it because it's like that's where people's minds first go to. But and so that's why I feel like there's certain misconceptions that seem more troublesome than they actually are, and then the real dangers are the ones that we not even really talking about. Because I was super shocked, and I don't know, did something similar. Hold on, it lowers the barrier to entry. Yeah, it lowers the barrier to entry definitely, but realistically, anything that requires like technical skill, y'all, it's not. ChatGPT is not that smart. Like it's good and it's coherent, but ChatGPT literally makes shit up. So that's the bigger concern. If you don't have any experience, you just copying and pasting stuff, you probably more likely to brick your own computer than than cause some harm to somebody else, to be quite honest. Um I think it's way more dangerous that let me see. LLM security risk. Oh gosh. It was a specific paper. No, it was a uh fake packages. Fake code packages. So yeah, but I'm just, I'm just a person on the internet giving my 2 cents. But LLM assisted malware review. I'm gonna try to find that paper or the report. It was a report. Damn. Let me see. Cyber, you said you did something similar to a course. It's not bad. Gives you general idea what their tier one analysts do. Okay, yeah. Okay, Preacher says AI can help you code, but there was a recent thing that showed it doesn't help in all areas. Okay, I'm gonna check that link out. I'm about to check. I literally just opened Discord too. Knowledge workers with ChatGPT are 37% faster, 40% higher quality, but 20% less accurate. Simple UX solutions to to solve this are possible. In a study of 69 students, the use of Codex improved their performance in learning Python, but it did not impact their manual code modification abilities. Yep. That's our current AI. The future versions, it might be even better. This is the worst. Yeah, this is also the most unregulated. So that's also a fun ride. We got to catch back up on the AI regulation conversation because I've been out of the loop on the newest hearings and discussions in that regard. A lot more, guardrails has to be implemented in future versions of the AI. So it will always become more powerful, but it will become a lot more restrictive as it goes along too. Wait, what is in the next 5 minutes? I'm scared. 5 to 10. How can you afford to do PhD without working? And are PhD programs paid for? Yeah, PhD programs are funded typically. The hard part is finding the lab and the professor and the right research alignment so that you can be under someone. But typically PhDs are funded. Preacher says there are quite a bit of PhD programs that are funded or offering teachership research positions. It depends on the type of PhD, yeah. As well as extra perks they are offering. Also, different countries have different structures. Yeah, so I'm in the US. Computer science, PhD in computer science is typically funded. And in addition, I'm applying to like top 10, top 20 programs. Those are all funded. They have very lucrative funding in their research labs. I remember doing an online test and I just used ChatGPT. I got 54%. Oh man. Okay. Still, I'm diving headfirst into cybersecurity. I hope it's a rewarding career. I love the concept of constant learning. Also, I get to tell my dates I'm a hacker. You gotta be careful telling your dates you a hacker. Don't tell them that. That might backfire on you. That would make me paranoid. Wait, you a hacker? Hold on, because like most people don't know what a hacker does. So all they think is like, oh, so that means you probably already hacked my emails and you already got my address and you gonna be standing outside my door when I wake up in the morning, or you only got this date with me because you hacked my account and figured out everything I know. I'm telling you, that's exactly where your mind goes to. Be careful, man. But you can say, yes. You want to spin it, you don't just be like, "Ooh, I'm a hacker." Now, if you go on a date with a tech girl, then that's gonna be different. But if you go on a date with like a typical person that don't know nothing, yeah, I'm thinking Mr. Robot all day, and all he did was hack everybody. By the time he met anybody, he already hacked them. People just know about the movies. They just know about the movies. But I can just give you a female perspective. Even though we some stalkers for real. We will, like, as a woman, if I go on a date with you, especially if it's cause now we in the social, online dating era, I promise you, I already know your whole life. You should expect that. Background check has been done, for sure. Got no social media, then that's gonna be a hard pass on me, actually. If I can't look you up, and you can look up everything about me, bro, like literally, I have no secrets. I mean, I have secrets, yeah, but because I am a speaker and a teacher and stuff like that, before I was a streamer, I have a personal profile online. So if I can't see nothing about you, I'm gonna question that. And you say you're a hacker? Welcome, y'all. Hey. Y'all trying to keep me up all night. That's crazy. Cyber is over here talking about telling people that they are a hacker on the date. What do y'all think? Okay, because y'all just came in. I just gotta get some fair opinions. If you were about to go on a date with somebody, you sit down and then they like, "Oh yeah, I'm a hacker." What you gonna think? Are you gonna be like, "Oh, that's amazing," or are you gonna be is it gonna be a little questionable for you? But coding with strangers, welcome in, man. I feel like I usually get to pass people off to you, so I appreciate the raid. Fizzy, was this the surprise? Surprise. Okay. I appreciate it. But welcome in, y'all. I haven't really done anything yet today, so we got at least a little about 2 hours of time to get stuff done. And hi, welcome. I see some familiar faces in the chat. I am Jessica, also known as Meta Dev Girl, also known as Meta. And yes, I was Meta before Meta was Meta, so we don't even gotta go there. Um, Normally what you would find on my streams, I am on 365 days of code this year. So um I stream every single day, and it depends on the day what I might be working on. The general buckets that I work on right now, I study machine learning and AI because I am getting ready to go back to school and pursue PhD, and research and teach in academia. That is like a 5 to 7 year journey that I am embarking on. Um, Planning on being able to wrap up a degree program so that I can apply to a master's by the end of the year, or by August. My deadline is August. So there's that. Then when I'm not studying, I work with a lot of startups, like building their businesses, helping them with their MVPs and things of that nature. So usually, depending on what I have going on, like one app is going into beta at the end of this month, and apparently another company that I'm working with just got into a really good accelerator. So there's gonna be, so I do a lot of client work, and what else do I do, y'all? I teach. I don't teach here typically, but I do teach. And you can find more content that I work on at metadevgirl.com, um, on my YouTube channel as well. That's something I'm building up right now. I have been in the field since about 20, 2016, 2017 is when I got into full stack engineering. So I usually I usually date myself from there, but I technically started getting into coding around 2014, and learned front end development. And then I started freelancing in front end development for a while before I decided I want to be full stack, and went and took a Java boot camp and whatnot. So yeah, I am very passionate about the community. So I am a co-founder of a nonprofit here in Detroit called Detroit Black Tech, where we just really like to highlight Black and brown developers, and also bringing more tech concepts and more skills to the Black and brown developers, and also highlighting Detroit as a potential for tech opportunities. It's not all about the Bay, even though the Bay is nice. I do love going to a good San Francisco conference, or whatever. But I'm really, really passionate about the tech community here in Detroit, where I grew up. And we also have a conference called Hacking with the Homies that we do every year since 2020. And this year's our 5th year anniversary. So I'm excited. And I know I've been saying that the website is going to get updated, and it really is. But me and my co-founder is just, we be all over the place. So forgive us. But yeah. Engineering Mind literally says it depends on how they dress. Okay. Rule number 1, a hacker doesn't tell other people that they are a hacker. What else? What's rule number 3? You recommended me for the raid. I appreciate it. Rule number 2, bots hacked my bots hacked my account. I'm a programmer, so my reaction would be, in what sense? This is all good feedback. Okay, look. Anyone looking for programmer advice, ask them. I'm living good though, man. I was doing my taxes all freaking day. Well, I wasn't doing the taxes, but I was getting all the documents together for the taxes. And this morning I just had to have a come to Jesus moment, which was cool. I took some space to breathe and get my life together and not stress about things that's in God's hands. And I must say I had a much better day after that. Thank you for the follow too, by the way, Bots1 and MDBM. I appreciate it. Cyber, also thank you for the follow. I feel like Cyber, you've been here before though, right? Does working in tech pay well? Oh, of course it does. Um, it depends on the job that you do, but yeah, it does pay well, especially depending on what you're comparing it to. At least for me, so I'm in Detroit, so our cost of living is lower than a lot of places, but regardless of the actual levels, like my first tech job back in what 20 my first software job in 2017, I think was like 50K at the time, and that put me in middle class because cost of living here is low. Um by the time I was like between when I got to like my third software job, I was making six figures. But then I left that world behind to be an entrepreneur, or to come back to entrepreneurship. But it definitely can be lucrative, but it I think Cyber, you said something about like being a constant learner. If you love to learn, then you in the right space, because it's just a part of our job. That's why I'm very passionate about it too. It's so like I love always learning something new. I love always like it's never you can never know everything. You literally can never know everything. And to me that's very exciting. Some people will find that daunting or even discouraging. I'm comparing mine to a retail or manufacturing job that goes between 16 to 25 per hour. Yeah. Yep. That's a big part of why I like it too. Yeah, so I mean, I really love learning. Like I always loved being in school. I'm actually excited to go back to school, as daunting as it can be and as weird as it is to say. I'm about to embark on something that's going to take another like 10 years. It's been a while. You know, when you come out of high school, if you're already expecting to go to college, like if that's already something that you know, then when you come out of high school, it's not weird to be like, oh, I'm about to do something that's going to take 4 years. And some people even already have the mindset that they're going to go straight to grad school, right? You already know you're about to do 4 to 6 or 7 years. And then if you know you want to go to med school, you know what I mean? You already know, okay, I'm about to spend the next decade of my life in school. But I've been away from school for a minute now. So it's very interesting to be like, it's almost weird. It almost feels like it feels a little daunting just because I've been out of the space for a while, but I'm excited because I love to learn. And that's why I'm excited about research. I think research will be so fun. Um Solving the hard problems. Always new material to learn. Yeah. And oh, excuse me. For me, I want to get into AI research. So of course, oh, excuse me. Of course, there's very little that there's well, I want to say there's very little room for boredom in the field. The thing about AI is that it's the hardware. The hardware has accelerated the field because these chips, the way that the processing power is like increasing, it has a big effect on AI in particular, because it's a lot of processing power to do some of the work that the research had kind of it's kind of like it's all this research that's already been out there for many years. It wasn't possible to actually put it into practice until now. Oh god, I'm sorry, I jump scared y'all. If I did, I apologize. Let me see. Oh wait, y'all can't even hear it. I just did that to my Wait, can you? Oh yeah, you can. I was gonna say I just did that to myself. Many decades for some agro. Yeah, heck yeah. What, like the 70s or 80s? Because I also like to under I like to underestimate how many years it's been because then it reminds me how old I am. So more like, because I be thinking like 30, 40 years, but like I am 33. So it's more like 50 years, 60 years. These new GPUs just chew numbers up. Yeah. And then on top of that, you got the massive Googles and Microsofts who just have like giant data centers and can like brute force. I don't know if I feel like nobody ever calls it that, but that's essentially what it is. You like brute forcing um massive data training because you have gigantic data centers and you can just you can just throw all this processing power at it. But now I could definitely say one of the areas of focus is for sure going to be like optimization, because right now it's just give it billions of parameters. Of course, if you train a model on every fucking piece of data on the internet, it's gonna be able to talk. Of course, a model that has 20 trillion parameters is gonna be coherent. Of course, but it's not practical in the long term if everything has to have that amount of compute power. So that does, that just opens up the door for things to explore. I also think from a research perspective, it's really interesting that um, we're introducing a lot of problems into the industry as well, right? So you have all these security problems, you have all of these um, like with LLMs, they hallucinate. That's a problem. You have there's different technical challenges that this new technology also introduces, and those are things that have to be solved as well. So every time you introduce a new area of interest, you also introduce all these potentials, probably even more potentials on the back end for how to fix the new problems that we introduce. So I'm like, there's no shortage of interesting work to do in the field. And then me in particular, since I'm really into education and helping tech education be more approachable and lowering the barrier to entry to tech education, making it be, yeah, more approachable really is the word. That's that's like a specific area that I'm interested in. I'm also interested in the overlap between like automotive and how machine learning could work in that space. Not really self-driving cars, but more so like predictive analytics. Um, like when I was in school, I was studying mechanical engineering and I was in the lab with one of our professors. He has an engine diagnostics lab. And I always, back then, one of the main reasons I wanted to get into machine learning, like the first project I really wanted to do was um predictive analytics for basically engine diagnostics. So let me know, like, oh hey, your engine is about to die in like 5 minutes, 10 minutes, 30 days or whatever. I think that would be really cool. Do you know any college level math courses you would recommend? I recommend not Code Academy. I recommend Khan Academy for the math courses if you need to kind of refresh. And I noticed too recently that I don't know the how much you can do for free on Brilliant, but Brilliant has some really good stuff for math as well. But Khan Academy, you can find anything you need. But if you want to take it for a course, then you could look at study.com or sophia.org. because on these two sites, they um they are accepted as transfer credits depending on how you complete the class. These two sites could possibly be accepted as transfer credits to universities. So they are also college level courses as well. So, but free Khan Academy is free. They have all the things. Almost damn near the majority of Khan Academy curriculum is based around like math in particular. Um, yeah. Moral problems are definitely another thing to consider as well. That's less research though, probably, and more the regulation of the field and the ethics behind it too. The advocacy part. Oh, I love the advocacy. That's why I'm going. That's another reason I'm going back to school and getting a PhD, because I want to do good work in the um in higher ed. I heard of quantum computers also. Yeah. I don't know as much about hardware, but definitely quantum computers is like a big thing. Um one of my mentors and like my old Java like coding bootcamp instructor, he I think that's where his research was in. Quantum computing. A lot of AI is just optimized brute force. Exactly. But it will get better. But we just have to come up with the newer tools and newer processes. So that's kind of what we were talking about before, where it's like um a lot of the foundational work that our AI is built on now comes from like decades old research, right? Like neurons, see, machine learning, neural network. The concept of a neuron, I think that's really old too, right? I should know this because I literally was just reading about this, but it was months ago. Um, I gotta get back into my research. Yes, yes. See, I get so excited about nerdy stuff. That's why I know I'm in the right spot. Um, so a lot of AI is also weighted decision trees, which goes a lot statistics under the hood and variances in confidence interval. Don't forget the resume. Oh yeah, I'm gonna send that. I just have to talk to you about it, preacher. I just kind of felt like I'm like, are my teaching samples gonna be like unique enough? I don't know. I shouldn't be thinking like that though. Mook.org is a great resource. I think it posted for you. No worries though. Just obviously please don't post spammy stuff in the chat because then you will get banned. But we're here for good, supportive, helpful resources. Oh yeah, I'll put the math stuff in Discord too. Which channel should I put that one in? I keep trying not to make new channels, but I do think that eventually the code channel is gonna need a little bit more segmentation. Actually, what I'm gonna end up doing is posting or making a forum channel, and because that way we can have separate topic threads. But I kind of don't want to. I thought I could convert the existing channel over, and I don't think I can. I wanted to convert the code channel into a forum. So then, like, if you have a code challenge or like something, you could post that. But I do almost feel like math could get its own section because I'm about to be back in math hardcore. So I do have experience with college math because I have been through Calc 1, 2, 3, differential equations, linear algebra, um, probably two physics classes. I took all the engineering. Well, mm, I took more than the engineering fundamentals because I was a math minor before I went into engineering. So I took a lot more math. I took all the calc classes, and when I was in school, the program we had, it was ABET accredited, but the engineering students, they took like a combined linear algebra differential equations. And like in computer science, I think you take like discrete math, but it's basically I took all of them. I took linear and diffie as separate classes. I took both of those independently, and I also took probability and statistics for engineers. But I have to retake all that shit because uh, all my math is over 5 years old. Neural network research started in the 60s. Okay, thank you for confirming that, because I'm positive the concept of the neuron is like one of the older concepts. I just can't remember the era because I was reading about those back in the fall. Check out Shor's algorithm for a really insane application of quantum computing. Oh, y'all getting me too excited now. Um, it just blew up in the past few years because of advances in hardware. Yep, exactly. Because now they can just throw processing power at it. So actually, that's one of the things that when I started getting interested in AI was back in 2017. Um, that's when deep learning became really, really popular. This is a 2018 article right here. Um, DeepMind, AlphaZero, OpenAI was just bursting into the scene, but they were, they stayed behind the scenes really. For most people, OpenAI stayed behind the scenes until ChatGPT. But I've been following OpenAI for a very long time. Relatively speaking, I guess you could say. They have been like my pinnacle, like, oh, I love. And then I realized that they were Microsoft plant. Then I just had to I had to take a little step back. No, I really do love the work that OpenAI does, but I be feeling some type of way about Microsoft all the time. But yeah, deep learning got really popular around 2017. Convolutional neural nets, LSTMs. Oh yeah, they got LSTMs on here. But they even mentioned attention is all you need, and it's funny because I didn't know. I don't think I really paid attention to that paper back then, because LSTMs was like the big thing that neural nets and LSTMs, that was the main thing. Because I've always been into NLP. So NLP is natural language processing. I've always been interested in that. So of course I'm trying to figure out how I really didn't pay attention to like the transformer thing. But now flash forward, and that's like really foundational for a lot of the LLMs. Quantum and optical computing, and then of course ethics. So yeah, 2017 is when I was like, ooh, I need to do this. I can ask my hookup, but it should be, let me know so we can both go for it. Haha. Part of this encode or dev reform channel will make more sense. Yeah, I think the form channel would be good. I just thought I think I'm gonna have to retire code, and I really didn't want to do that because it's such a good channel. I don't know. Oh, exclamation mark Discord. My bad, y'all. Don't retire code. No, but that's what I'm saying. Like if I if I when I was looking at it, because I converted the server over to community server, I don't have the option to change the code channel into a forum. So how will we do them differently? Yeah, it would be more of an archive. Like it would still exist, but then we would no longer post in it, and it would probably just point over, say like, go follow the go jump in the code forum. But I'm open. Y'all can give me all feedback on how you want the stuff to go, because it's for all of us. So I just be trying to do something that makes sense organizationally without adding too much overhead to to the channels. LSTMs really just excel in sequential pattern analysis. Guessing the right activation function is 50% of the fight. That's fair. But it was funny because it's like the version of quote unquote breakthrough that we had back then was more so like, oh, you could be like, oh, let me train like a model on uh like Drake lyrics or something like that, and then get the model to like make you a song that's similar to Drake. It's so funny because we had started this program back in, I think we started in 2017 or 2018. It's called TrainX.ai, which if you follow the streams here, hello, if you follow the streams here, TrainX has been it has been reimagined. We have come back with a podcast. I should be able to get to this. But anyways, we had started a training program because we wanted, like, especially Black and brown developers, we wanted them to, a lot of times we be lagging behind in what's happening in the field. So we're like, hey, this is something that you should know about, because this is going to become an essential tool for developers. And I think the project that they were doing, our first cohort we had, the project they were doing was like a rap bot. And it was supposed, I feel like it was supposed to combine the styles of like, I want to say like Drake and Eminem, and it was like Tupac or something. It was like, I think those were the three. Combine the rap styles of Drake and Eminem and Tupac, and then get it, basically to produce a new song. And yeah, it was very easy to get incoherent babble from your language model at that time. Okay, let me post some of these links. All these links. Okay, so we're gonna post Khan Academy. Oh, brilliant. I'm just going to submit my freaking resume, okay? Actually, I already have a resume. So, I need to write my cover letter. I think that's what it is. Then study.com. Oops. Dang it. That was not exactly how I wanted that to turn out. Edit. Command X. Save. Delete. I want it to be perfect. Perfect. And then Sophia.org. Okay, I did it that time. Why study.com not showing? It's the right one. Okay, let me see. Ooh. Y'all know AI. That's really, I love it. Preacher, do you want to be a Discord admin? A Discord mod? Code forum archive. I really like the LSTM. Okay, I'm just trying to make sure I catch up. Oh, I really like the LSTM. Yeah, why not? Mom me up in Discord. I got you. Cause you can make some stuff, like you can do whatever the heck you want. Just don't go crazy. Don't all of a sudden become a crazy person. That would be terrible. But I feel like you do a lot of the conversation wrangling. I really like the LSTM and some of the early 2010s in AI. I really was enjoying AI when I first got exposed to it. I still love it now, though, of course. When people were making their own training sets and boutique AI. A colleague and I trained voice models of ourselves today. It was hilarious. One time I had Bart do a rap battle with ChatGPT. That was funny. See, we need to do that. We should do that on the stream. Pin this right here. We will talk off stream. Yep. I'm gonna hit you up, but I do think I should just like submit my resume. Do I look like I can go crazy? Give me a false answer. No, of course not. No, no. You didn't just make me do some random ass freaking programming language the other day. No, of course not. What the heck? Y'all just came in full force. Hold on now. Like, I can't see the link. I can't see the names. Y'all have to get personal welcomes because I'm really serious about this. I have to do it every time. Y'all about to get tired of my welcome gifs because I'm very, oh wait, no, that's not the one. I don't want that one. Go away. I'm very particular about my welcome gifs. It's funny because like now you can just do the stickers, but I've been doing this since before stickers was a thing. I have to post 3 because it's 3 of y'all. It's a collective welcome though. I have to give my personality traits and gifs. Fun fact. The Godfather is literally my favorite movie. Okay. And You know what I wish? I wish more people had the same name in Discord that they have in that they have in Twitch. I'm like the only person that's like everything should be the same. Microsoft released their annual Future of Work report, and this time around, it's not about remote work, it's about AI. There's some good AI reports out. No, I don't want another language. What the heck? I learned emoji code. That was good. I think I did a pretty good breakdown of emoji code just by looking at it. I discovered the main methods, the code blocks, how to distinguish a string. That was really good. I love her accent. She's a great MC. Okay, if y'all know anything about embeddings or vector databases, I have not actually gotten to even research what any of that even means, honestly. I have my own like general understanding of like embeddings and vectors, but this is something that has been talked about a lot recently in the AI context. So I had been wanting to, just do some research and understand a little bit more about the applications, and then I saw that it was one of the topics they were going to cover for this. So I was like, yes, I'm excited. I'm very excited about this. This is literally the main talk I've been excited about so far. So if you just want to get like a quick overview or a brief overview of what we have looked at so far in this series, let's see. Oh, the first session was like a current state of AI. So it was a little bit of like background terminology, the applications of LLMs, and then the second session they got a little bit more into what makes a good or a bad use of generative AI. Because people just trying to apply AI to everything nowadays and just stick AI on anything, and it's like, no, don't do that. So they kind of set the stage for that. And then in the second week, we got into prompt engineering and image generation. The prompt engineering was really, really cool because even though I'm familiar with like prompting and stuff like that, they talked about some of the best practices. They talked about the chain of thought methods, and they talked about the React method. So that's something I'm still learning more about. But I have a practice notebook that was assigned for us last week, and those were kind of good to explore. So when I get done watching, well, actually, after I processed the video for today, because this was the video I'm about to watch was today's session. So after I processed that video, when I get back into doing labs and stuff, the first thing I'm going to do is actually pick back up on the chain of thought and the React methods. So those were really, really, really insightful for me. And another thing that came out of that was some other general best practices, which were really awesome. So, and Tristan was awesome. Depending on which time zone you watch, there's actually they do them live, and there's legitimately like different presenters for each. So I haven't seen any of the EMEA APAC presenters. I've been watching on America time zone, obviously. So Tristan was super awesome, and Jeff was pretty cool too, but I really liked Tristan, and he has a lot of good examples. Jeff talked about image generation, and if you are familiar with Google's tool sets, they have a new feature coming called Imagine or Image Gen, and those of us that were on the class live last week on Thursday got preview access to Imagine. So I actually have access to Imagine right now in Google Cloud. which is fun. So I get to play around with it, and they showed some business use cases for Imagine. Like, you can actually take existing products, show, like, get Imagine to change them into maybe like different designs. Like, he showed an example of, like, here's a tote bag, and then get the tote bag to be denim instead of canvas, or get it to be leather instead of canvas, change the colors of it, or get a specific product and change the background, so that you can have marketing material for the actual product. And let me see, what else did he talk about? Mostly it was the part where we got Imagine preview access, because Imagine's supposed to go public in at the very end of March. So for now, that's a good little plus that we got as a part of being on the class live. And yeah, so that was week 2. So this week is code generation, completion, chat applications, which is tomorrow. Today's session was deep dive. Well, tomorrow as in Thursday. Today was about deep diving into embeddings and vector databases. So just to give y'all a background, that's kind of what we covered so far. And then this is a 6-week course. So next week is retrieval augmented generation. I know it's right there on the screen, but I was trying to look at it. Retrieval augmented generation, using Vertex AI. So that's another strategy that they talked about, because that's related to the React method as well. But it'll be nice to kind of dive deeper into that, because that's a practice I haven't really implemented before. And then building enterprise chat apps, which I'm very interested in from a business perspective. Have some potential client work in that space. Week 4, that's week 4. Week 5 is deploying and hosting in the cloud, tuning and reinforcement learning with human feedback. So those will be awesome. And then they also have to get into ML ops and stuff like that for us. So the final week will be model evaluation, and also application development with Duet AI, because that's a specific tool that they have in the cloud as well. It's more geared towards business applications. So yeah, this is it's really, really cool. This is here. I'll put the link, but I guess it's probably not even easy to find it as much in the AIMO channel. I'm gonna repost it though. This is Google Cloud. And then if you do get involved in the class while it's live, then you will get you can get access to credits, so that you can actually do the labs on their platform. Why can't I find I'm already in it, that's why. I'm like, why I can't find the AIMO channel? Where's Preacher? Roles, admin. I think you have been elevated, Preacher. I did some embedding stuff on OpenAI, trained a chatbot to only answer based on a few texts that I embed. Shit is rad. See, y'all getting me way excited about it. Whenever I hear people say we need a new language, I remember the XKCD strip on standards. Oh my goodness, I feel like I don't look at XKCD enough. And I remember, I just realized that I think I was looking for something on my phone the other day. Yeah, I was looking for X, or maybe I was looking for Xfinity, and found out that I never deleted the XKCD app off my phone. I might end up being up late at night scrolling. Whenever I read that one. Imagine looks dope AF. Where do you join these classes? I reposted Botswan, you can find it in the AI ML channel. I reposted the link, but it's cloudonair.withgoogle.com. So any of the past sessions, you can watch the recordings of them. And I don't know if you'll get Imagine access, just because I think they did that for everybody that was live on Thursday. But definitely highly recommend the material. And then they have, like I said, they have credits for the labs. We got like 200, I think we got 200 credits. And let's see, these are the most updated labs for this week. Oh, dang, they didn't even do the whole week. Last week, they gave us Tuesday and Thursday labs at the same time. This week, we only got the Tuesday lab. So this is, oh gosh, why does this stress me out every time? And I always say remind me later. This is the this is the notebook for today with embeddings. Okay, so I'm going to open this one in Colab. Actually, I did set up my account and stuff, so I should be able to run this. All right, give my computer a break. Not that it really needs one. But yeah, so if you do the course, you can get your credits. I need to apply for this. You can get your credits. Let me see, where's the labs again? This is the lab stuff. And then this link at the top gives you the instructions on how you can get your lab credits. They basically send you confirmation, and then you can take the quick labs overview lab, and once you finish the quick labs overview, then you'll actually get your 200 credits. And it does not take 9 credits to do the quick labs tour, but it's just a starter. All right, so let's go back here. People are all about using AI for things. Clustering and sampling already excel at way faster and way cheaper. Yep. How goes it? It's going pretty well. S4, how are you? We just in here getting the chat on, but I am about to start this this workshop recording because I didn't watch this live today. Why do it keep being so loud when I open it? Oh, it's their music. That music is loud. All right, we're gonna turn off the AI music. We've been listening to AI generated music, by the way. I have like the Moobert stream thing because I have to worry about copyright claims and stuff. Making languages is fun. Preacher, I could definitely see you being one of them people that's like, you have kids that randomly just know completely made up languages. It's like it's not even a language that exists. Okay, this is a long little intro. This is an hour and a half, so I want to finish this and then I'll go to bed. See how quiet her voice is compared to the music? Working on spelt. Solid. A spell app. Oh wait, can y'all hear it? Oh, I know why you can't hear it. Hold on.
We also have sessions that you can watch back on demand, and after this class is finished, you'll be able to review everything that our speaker is about to cover. During sessions, speakers will cover either notebooks or code labs, and we give you all the instructions for where to find all of those. They'll do that during the class live, and we have it in a blue banner above my head now, and we'll also share that information with you in our follow-ups. Some of the labs that our speakers will cover are available on Cloud Skills Boost, and some of them have certificates if you complete certain labs and courses. And you can see that in
So
Cloud
I'm
Skills Boost.
wondering, are they putting
It has all the
these?
instructions that you
Oh
need
no,
for
they're
the
unlisted.
labs that give
Okay,
you
that's
those
what I was
certificates.
wondering.
All the instructions that you need for the labs that give you those certificates. A little bit more housekeeping. We have a Q&A function at the bottom underneath where I'm currently visible to you. Please ask your questions and participate in the
I
class
kind of
that
feel
way.
like it
We've
might
got a
be
brilliant team of
overkill
experts,
for
AI experts
for y'all to
in the
hear the
background who will
housekeeping
be
and
able to
stuff
answer
because it's
all your
not live
questions that
today
you send in.
for today.
Each
I
class
don't
does
trust
end
people
with a
with
live
British
Q&A with our
accents. I
instructor, so
love
do
people
hang
with British
around at the end.
accents.
We'll save the last 15 minutes for the
Now I
Q&A.
feel
And
like
any
Cyber, how
questions
you
that
gonna
you
say
see
that?
your
You the same
fellow
person talking
attendees
about you
watching that
just
you
gonna
want to
tell
have
people you a
answered, just upvote
hacker.
them so that we know those are the ones to ask Deb.
Others are gonna treat you the
Classes are
same
going to be
way,
recorded,
like,
as I
oh no,
said, and
you're a
you'll be able to watch
hacker.
this one back as soon as it finishes at the end of today's class. Lastly, we won't be sharing slides. Labs are available for you to complete on Skills Boost at no cost, and we'll share all information on how to access our GitHub repo and all the ways that we can provide you with credits to complete those notebooks too. Last thing from me, as you probably know, we are using Practical Labs, as we've mentioned before. To be able to access these labs, you need to create and fuel your account on our Cloud Skills Boost platform. Very easy to do that. If you haven't yet done it, we've sent you instructions over email, but if you can't find that anywhere, scan that QR code now, follow all the instructions. Really important to note that you do need to finish the introductory lab, which should take you at least 6 minutes. And from there, give it a little minute and credits will be added to your account. Any questions, please email the support@quicklabs.com alias. Got a brilliant team waiting there to answer questions that you might have. Okay, without further ado, I think it's time to bring on Deb, who's going to be leading our class today. And here she is. Hey, Deb.
Oh, and she
Hey,
has the
Lisa.
wonderful
Thank
fake
you.
background. Love it.
Cool. So, hi, everybody. So, Deb Lee, I am an AI machine learning customer engineer here in our London office. Pretty excited to talk to you about embeddings and vector databases today. So, as we had mentioned, everything on here that I'm going to be showing you today is readily available for you to get started with. So, for
Probably
example,
because
the
of
notebook
James
that I'm
Bond.
going to take you through, this is using publicly available sample data. So hopefully coming out of this, you'll both have a better understanding of why you should care about embeddings and vector databases, why they're useful as sort of a
Yeah, let me get
core
my
essential
notebook
building
out
block.
because I have been
We'll be
taking
covering retrieval
notes.
augmented generation on another session, so I won't
I
be
don't
covering
look
that.
back at
But
them, but I'm
also,
sure I will.
where you can go to actually get started from a tooling perspective and how to get started. So yeah, let's get into it. I had mentioned that, vectors and embeddings have actually been around for a long time. So pre GenAI hype wave, right, in the last year, it's just not as many people cared about them. And I think a big part of that was because, what we're seeing is that these types of systems where you can integrate semantic search using vectors and, vector algorithms can give you the sort of fill in some of the missing gaps from what core generative AI models, language models, especially can't do off the shelf. So in this example here, what you can see is that you might have embedded a specific data source, right? So the facts that you want to ground them with. Potentially, you might have quite a bit of information, right? So it's not going to necessarily fit in a context window for a language model. But what you really just need is a little bit of the most relevant context for the language model for it to be able to just answer that question. that's where sort of super performant search, so a similarity search against vectors, becomes quite relevant, where you can then feed it to the language model to then answer someone's question and then give you that output. So we're really seeing a explosion of adoption of vector-based approaches, and I think this is sort of the core part of the core reason why. And also just in terms of the information, make search available, natural language interfaces. So it's all sort of coming together. But let's start with some of the basics, right? In terms of actual embeddings, retrieval, similarity search, those types of things themselves, before we jump into the labs or the notebooks and sort of show you how to do it. So let's level set a bit here. So when we talk about vectors and embeddings, we're talking about a mathematical object. So a vector has its direction and its magnitude, its size. And when we talk about vector embeddings, it's basically just a representation of some type of data. So in the context of language models, you see a lot of vectors representing, basically chunks or strings of text. So maybe it's a tweet, right? Something like that, but it could also be an image. I'm going to show you some examples and talk you through the power of vector search on sort of image search, so text to image or images to images. So you can turn anything, right? Any type of sort of unstructured data into a vector if you have a model that supports that type of turning something into a vector, which is cool. So we can start to represent everything in a consistent way. Once we have represented it in a consistent way, this is how AI can sort of better organize the data using the embeddings. So like an embeddings model, you're going to consume it, meaning you're not going to actually train it yourself. So we offer, Vertex AI, we have a multimodal embeddings model that you can use. So that's the one we're going to use like in the lab today. And it's already been trained with specific content, right? So like text, images, tweets, whatever. But AI is creating a space, which we call the embedding space. This is effectively how we map the content's meaning, right? And so, the AI model is going to then identify the location of each of these pieces of content on a map, right? And so that's kind of what the embedding actually is. So if you take this example where we have a piece of text that's talking about movies, music, an actor, with distributions of
Productive time.
10%,
Thank you for
2%, and 30%,
popping in.
we're going to create this embedding with these three values. So it's 0.1, 0.02, and 0.3. In this case, in a three-dimensional space. This is obviously an oversimplification because in reality, your embedding space, and we'll see some crazy diagrams in a bit, may have like hundreds or thousands of dimensions. So obviously we're simplifying this so we can actually see it on here. But that's the power of this, right? Is so we can start to represent all types of information about everything in the world across these different categories and in terms of content. And where this becomes useful for us, so how do I use this, is that now content that has similar meaning is going to actually be close together to the other pieces of content in this space. If you've ever ventured into some of the like Google ML crash course contents,
Yeah.
they typically tend to refer to creating as embedding as the process of mapping from very high dimensional raw data
I
to
also
think,
still highly
millions
recommend
of
that.
tweets or millions of images and
She's
tons
talking
of
about
documents and text or whatever.
this Google ML crash course. I still recommend this. I think I posted a lot in the channel, but I always have to come back to this because this has been around for a while and it's really good. And it kind of looks updated. Let me see. Look, freaking what's his name? Peter Norvig. Am I making that up?
Welcome to the Machine Learning Crash Course. My name is Peter Norvig, and when I joined...
Classic, man. Ooh. It's giving me 2017 in the best way. But yeah, this has been around for a while, but they do keep it updated and foundational material wise, like machine learning concepts, I highly recommend. I'll probably go through this material again soon. But this one and fast.ai, um, practical deep learning for coders, this is really good too. Both of these are good and they're free. Practical deep learning for coders is a little more modern in a sense, because this one will talk, you will learn about ML concepts, but it's more so putting the newer using the newer machine learning applications, I guess you could say. And fast.ai is actually a ML framework or library maybe. So if you use, is this it? Yeah. If you use go to docs.fast.ai, you will find the fast AI material, which you can use a lot of the tools that they have available in order to implement machine learning into your software applications. So more so high level stuff, but they have some low level. I think they have some low level APIs as well. So it just depends on what you're interested in or how deep you're trying to get with it. So shout out to those things. I'm gonna repost those links too, but I think I usually post. I'm sure I've posted those at some point if you've been in Discord for a while. Let me see.
Those of you who are new. The structure of Startup School is as
Wait,
follows.
what?
We have live.
I just confused the heck out of myself.
Whatever. So that could have data. So obviously we're simplifying this so we can actually see it on here. But that's the power of this, right? Is so we can start to represent all types of information about everything in the world across these different categories and in terms of content. And where this becomes useful for us, so how do I use this, is that now content that has similar meaning is going to actually be close together to the other pieces of content in this space. If you've ever ventured into some of the like Google ML crash course contents, they typically tend to refer to creating as embedding as the process of mapping from very high dimensional raw data. So think millions of tweets or millions of images and tons of documents and text or whatever. So that could have millions of dimensions associated with it to a more usable lower dimensional space. So maybe we have hundreds, right? Or maybe 1,000 dimensions. And this is using a deep learning model. So that type of model, for example, is our embeddings model that we're providing to you for you to use. So yeah, the point of this is that we can then extract that meaning and the semantics of the data to then the context. So we have created our vectors. We've used some sort of embeddings model to generate those vectors. So where this becomes quite cool, I would say, is that now we can start to do things like calculate how similar two vectors are to each other, right? So that when we talk about similarity search or vector search, this is oftentimes fundamentally referring to how close are basically this vector to some fixed number of other vectors based off of a mathematical calculation. Yeah. So this is this type of similarity search has been around for a long time. Think recommendation engines. So maybe on YouTube, when you get recommended another video showing up sort of on the side next to you, targeting and adjusting advertisements for users, image similarity search. So find me similar images to this image, answering questions, chatbots. A lot of times this is already being powered by vector similarity search. Inside Google, this is something that we've been using for a long time for YouTube, Google Search, and Google Play itself. So this is where it starts to become really powerful. And if you remember that first diagram that I showed, context is king when we're talking about AI, generative applications, working with LLMs. So if you can just build something that's able to pretty quickly give you the most relevant bits of context that the model then needs based off of what you're asking about or searching for, in a small enough period of time, this is how you can start to develop really powerful
She
applications.
just opened
Yeah,
up
so I
my
mentioned
whole
before,
mind with her
this is how
overview.
Google organizes our data for things like YouTube and Play. And think about it, don't think about it just in the example that I had given before, but that embeddings can be used to represent different types of things in businesses. So it could be representing products, it could be representing users, user activities, conversations, music, videos, right? So you could embed videos and the meaning behind those videos, signals from IoT sensors. These could all be turned into vectors themselves and then accessed in the same embedding space, right? So maybe you want to ask a question about some topic, right? Some user activity or something, and you want to search across videos and social media tweets and mentions and signals from and images and things like that. It's possible to search across all of those once they've all been turned into vectors at the same time. So quite powerful.
Oh my gosh, you're
To
making
give
me
you
so excited.
uh,
I need to
a
do
quick
something with
look,
this.
let's see what a real embedding space looks like. So this is an embedding space for handwritten digit images. So these embeddings are being grouped based on how similar their actual shapes are, right? And then this one is another embedding space for text sentences. So you can see when you're hovering over, we're seeing similar sentences. So they might be in different languages, but the sentences with similar meaning actually end up being grouped together in this case, in this embedding space. So yeah, this is just to try to give you a sense of what does this actually look like when we're accessing it, and why when you do a similarity search, are certain results being retrieved? It's because they're all close to each other in that little space together. Yeah. Okay. So we're seeing a major shift in terms of being able to organize data into embeddings to represent user intention, products, things you do business. So I think that this is going to become sort of the new standard in terms of building these into different different applications. And when we talk about the types of algorithms that are actually being used to perform vector similarity search, so Google open sourced Scan, and this is what we use for our own internal services. It's also the similarity algorithm that's built into our
My bad. Hold
managed
back. Hold on. I gotta go back a
vector
second
search
because
product database. So you're going to be,
I was
and this
hearing
is what we
something.
use for, right? And then this one is another embedding space for text sentences. So you can see when you're hovering over, we're seeing similar sentences. So they might be in different languages, but the sentences with similar meaning actually end up being grouped together in this case, in this embedding space. So yeah, this is just to try to give you a sense of what does this actually look like when we're accessing it, and why when you do a similarity search, are certain results being retrieved? It's because they're all close to each other in that little space together. Yeah. Okay. So we're seeing a major shift in terms of being able to organize data into embeddings to represent user intention, products, things you do business. So I think that this is going to become sort of the new standard in terms of building these into different different applications. And when we talk about the types of algorithms that are actually being used to perform vector similarity search, so Google open sourced Scan, and this is what we use for our own internal services. It's also the similarity algorithm that's built into our managed vector search product database. So you're going to be taking a look at this today. So just to give you a sense of behind the scenes, how is this actually doing it? And this is open source too. So if you wanted to get really deep in the weeds and start looking at how it's built, feel free, go ahead. It's also the point on this chart. So I think useful to be able to read this chart in the sense that in terms of the speed or queries per second, this is not going to fall over. It's built for scale. So this isn't going to fall over when you hit, 500,000 users or 2 million users or something like that on your
High
application when you're needing to
accuracy,
do
short
search.
latency.
And you're going to maintain the same or better level of accuracy for that high volume of queries and throughput. So yeah, hopefully that gives us a bit of an orientation into
That was a
embeddings,
great
working with
orientation.
vectors,
That was like a
and that
fantastic
side of things.
orientation.
So we don't have a Cloud Skills Boost lab for you for this section, but I would heavily recommend exploring this notebook to get started with vector search. This uses a public data set, so it's not like you need to import a bunch of data to be able to get started with it. And I'm going to show you in a minute how you can stand up a Colab notebook or a Vertex AI workbench notebook to be able to actually execute this code and go through it step by step. But first, I think useful to probably give a bit of context. So in terms of the tutorial, I had mentioned before, you can run this in Vertex AI Workbench, or you can also run it in Colab. So really up to you. Hopefully you have access to a Google Cloud project and you can sort of get in there and
I already
start
set up a
using
Google
some of the
Cloud
services
project, so
themselves.
I
If
can
you
run my
want to
collabs.
calculate the cost, feel free to take a look at the pricing calculator. I think this has a handy little cost estimator, but I think you hopefully have access to some of the credits from a startup school perspective, so you could probably use some of those. So when we think about GenAI and bringing LLMs in, I had mentioned before, we have tons and tons of data that we want to make sure that our language model has access to. We want to ground it. And to do that, we need to use our embeddings with vector search. So you can see this little short video here. This is actually a Stack Overflow semantic search demo. So if you want to check this out, feel free to go check out the live demo. You can see the link in the GitHub repo. I have it here. So this has already created embeddings over all of Stack Overflow. So you can come in here. What we're doing is we're just doing a text semantic search, right? So let's say I'm getting this error, right? No module name my project. So now it's retrieving the most relevant results, and it just searched across 8 million different different Stack Overflow results. So that was pretty fast. You might have missed how quickly it returned those results. So let me just do another one. Okay. Wow, so pretty fast, right? You can see I just did Wise Python faster than Ruby. And we can start to see the different, and it's going to take me to the Stack Overflow. Ah, cool, thanks. Because we've given it like the source URL from a metadata perspective. So this is basically showing you the front end of the behind the scenes, which we're going to get into today. And so we're going to actually build this out using the Vertex AI Embeddings API and vector search. So in a traditional IT system, you might have thought about tabular data, right? In terms of keywords or labels and categories. So I have this column with this name, and I do a select statement where city equals NYC. So sort of this is not what we're going to be doing when we do this type of similarity search. So if you remember before, what we're actually going to do is first step, generate the embeddings for the system of interest. So we have to do this, it might be a one-off effort and then like a continuous stream behind the scenes that keeps updating our embeddings. But either way, we're going to be actually performing search against our vectors. So once we have that content, it's saved in our embedding space, and we find that embedding to point to a location and the map of meaning, and we bring these back. So hopefully this is familiar, because I just covered a few slides on this. Shouldn't look too crazy. And there's some link here too. So the Google ML crash course link is also quite nice as well, if you're interested in this. So we have our own embeddings model that I had mentioned before. This is the one that we're going to be referencing. We're calling it programmatically as an API. And you could take a look, though, if you wanted to see. It's available on the model guarding here, too. You can see the embeddings. I had mentioned a few of sort of the use cases before, but really what this can do is empower various different use cases for LLMs. I think most important is the ability to now bring back similar documents and then give those to the LLM at real time. I'm not going to, good about the library in action, but let's get started with this. So before I start, going through and running this whole notebook, I think it would be useful to just show you the different options that you could do to run these. So within Vertex AI, so if you just go to Vertex AI, I'm in the GCP console here. To basically have an environment ready to be able to run this notebook, you could start off by going to Colab Enterprise, and you could create a new notebook. You may have to create a new runtime if you've never worked with this before. So you can see connect to a runtime. If you don't have an existing runtime, you may have to create a new one. give it a new name. So, that might take a few minutes. And also, if your runtime is turned off, it may take a few minutes to spin up again. So you could go through and execute this code, this Python code in a Colab notebook. The other option from a Vertex perspective is, so let's say you were at Vertex AI, is to create your own workbench notebook. So the main sort of difference or benefit is that the Vertex notebooks are going to give you more flexibility to customize the underlying environment itself, meaning, just customization in terms of packages. Let's say you wanted to start off with a certain like runtime environment or attach a GPU or something like that. So what you can do is you can create a new workbench instance, choose where you want it to be running. As I mentioned before, there are different runtimes you can give it. So you could start off with just Python 3, or if you knew you're going to do something with TensorFlow, for example, sort of choose where you want this to sit. I'd mentioned you could attach a GPU and then have it automatically install those GPU drivers. You can see once you make selections, you'll get an estimated monthly cost because this is effectively spinning up a little machine for you to use behind the scenes. And so we do have idle shutdown. So if someone doesn't use it for more than a certain period of time, let's say 20 minutes to an hour, something like that, you can make sure that it turns off. So obviously the cost estimate is going to assume you have this on all the time. So that's how much it costs per month or per hour. Anyway, so I've already created one. And if you click Open JupyterLab here, this is going to launch your JupyterLab instance. So what I've done to run this lab is just, you can basically create a new terminal here, which I already did, and run a git clone command for the generative AI repo. So if you do git clone, this should copy the generative AI repo into where you should be working in the Jupyter Lab. So you can see the repo here. We're starting off, if you go into the embeddings folder, and then we have the intro text embedding vector search notebook. So this notebook should look familiar because this is the same environment, sort of what I was walking through earlier. But now we actually have this in a runtime environment. So I'm going to step you through this notebook and sort of explain what's actually happening in it, because I think this will give a good sort of live hands-on example of how you could do the same thing yourself. I'll then probably come back and talk a bit more around vision embeddings and vision sort of text to image or image to image similarity search and some of the considerations there, because I think it's quite powerful when you start to combine things like multimodal as well. So you might have a lot of unstructured data and maybe it's not all text, maybe some of it is image, some of it is video, and you might be able to get a lot more value out of it. So first, you'll want to make sure that you have pip installed, the upgraded your environment. So this will, if you're working in a Vertex notebook, you'll need this user flag, AI platform, and a few others. So you'll want this to run. It's going to install everything for you, and then you'll need to restart the instance after you pip install all those packages. So you could do that here by executing the code that's in that cell, or you could also go up here and just hit restart the kernel. Same thing. So wait for it to restart, right? And then it should be good. You should be able to execute. So you can see here. Always make sure that you are setting the project ID whenever you're doing anything in Google Cloud, because once you're using a lot of services on Google Cloud, you'll probably have multiple projects. So want to make sure that you're just you're working in the right one. If you're working with this in Colab, you'll also need to run an additional authentication step within Colab. If this is your first time potentially working on, Vertex or some of these other services, you probably will need to enable some additional APIs in this project. They might already be enabled, so in which case this won't do anything. This won't take that long, but you'll get a message saying, okay, this finished successfully. And when we say enable APIs, this is sort of core to how you work with our services on Google Cloud. So everything is an API under the hood. So G Cloud is kind of just a wrapper for other API services. So it's a Google Cloud specific one. But yeah, so this is enabling, making sure that the AI platform, storage, et cetera, are all up and running. Okay. So the other thing you might need to do to get this notebook running is to make sure that the service accounts, so the back ends, whatever's going to be making the calls effectively to update or create the embeddings, for example, or to insert them into vector search, we want to make sure that we have these IAM permissions updated. So this is a nice screenshot because I think it kind of shows exactly what you'll probably need to do from identity access management. So if you go to the IAM page in the console, that's actually outside of my little notebook, and it'll be here, IAM and admin. Make sure that this is, for the compute default service account. So this notebook, this Vertex notebook, every API call that's made out of it is actually using this service account, right? So we need to make sure that this service account has enough permissions to be able to do the things that we're going to run in this notebook. So what you'll see is you can go into, IAM, and you'll see your service account here, and then you can update its permissions. So this screenshot is pretty good. And if you already have these permissions on it, when you click on it, you'll just see that it already has it. So that's fine. So someone maybe already added them, maybe you already added them. Cool. So let's get started with some of the embeddings pieces. So I already showed the Stack Overflow public data set. So this notebook example is just using a subset of it. We don't want to actually go through and run this for all the 23 million rows that are in that data set. But this is a publicly hosted data set on the Google Cloud side. So you can see the way that this data set is referenced is BigQuery public data. So that is the project. So it's hosted in a Google public one, and then it's the data set is Stack Overflow, and then the table is posts questions. So anyone who has access to Google Cloud Console can access all the public data sets. So if you haven't seen them before, you're just interested, it's usually worth checking out. There's some interesting stuff in there. So we're just going to use 1,000 rows, right? So let's basically export into a pandas data frame. So it's only 1,000 rows. We're not going to hit any issues in terms of like memory limitations, most likely here. So don't need to worry. This should be pretty fast. So I can just run this cell, and you'll see now we can see a sample of the top of this data frame, right? So this is the BigQuery Python client, which is quite nice when you, let's say, want to execute a SQL statement, select blah, 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 and then read it, let's say, to a data frame, right? So this is a nice sort of interoperable way of sort of quickly reading data in and out of BigQuery and then working with it in Python. So we can see, right, a few example titles. This looks right? So what is the correct way of installing Firebase? Error when trying to install React Native project. So these rows are going to be what we're going to embed, right? So now let's, so we have this in our data frame, right? So data frame, cool. So with the Stack Overflow data set, we're going to use that title, yeah. So the title is really just like the question title, like when you go to Stack Overflow, if you're not familiar, right? So this guy, and then we're going to generate an embedding for it, and then we're going to use the embeddings API from Vertex. So this is a nice example of how you can get started with it. So you're always going to need to instantiate Vertex AI. I would highly recommend always passing both the project and the location. So Vertex will run in a region. It will run in, let's say the region is US Central Run, or it'll run in Europe West 4. So always good to keep the location coded in there. And then we're going to use the text embedding model. So this is the text embeddings I had mentioned that we provide as a service, meaning you don't have to train it. Rather, you instantiate it and you consume it. So you just use it. You pass it information, and it generates embeddings for you. Get this question a lot, so might as well just preempt it in case it comes through in the Q&A. So if you're using the Google Cloud generative AI models, we do not save or consume any of the data that you send to those models. We use it to process and then give you an output. But so we don't store anything that gets sent to it on our side ever. So it's up to you. You have to store those generate embeddings to make sure that you can then use them and put them into a vector database so that we can then do a search with them, right? So you got to save them. Okay, So we've instantiated Vertex, and we're going to use the text embeddings model, right, which is text embedding gecko. Feel free to take a look at some of the documentation around the different models that are supported. But what's cool about our embeddings model is that we also have multimodal supported. So let's say you wanted to embed some images and some social media tweets or something, and some document stuff off PDFs. You could use the same embeddings model to generate vectors for all of those. You don't have to switch between them, which is good. And also, if you were switching between embeddings models, that's probably going to impact the results, and definitely not recommend to do that. So Peter asking you to speak a little slower. Yes. Okay, I will speak. Yes, I see. So try to slow down a bit more. So we're using a text embedding model in this case. However, sort of we have a number of multimodal embeddings models which are also supported. So take a look at the docs, and that means that you could use the same model and pass it images, videos, text strings, social media, things like that, sort of all to the same. So, we're going to use the get embeddings function to get these embeddings. You can pass up to 5 texts at once in a call. However, there is going to be what we call a quota limit, kind of. So this will be a limitation by default that's set for request per minute. So this will be for a default project, but we also can help you raise that quota limit. So you can raise a quota limit increase request to get that raised, or you could also define like a wrapper to help you effectively batch it so that you don't run up against that quota limit. So just something good to be aware of when you are working with some larger scale applications. Yeah. So here you can see we're going to do this is the definition get embeddings wrapper of these texts. So this is what's going to generate our embeddings for us. So this bit of code down here, I've already run a lot of this because sometimes it does take a bit of time, but I want you to be able to see the outputs of what's being generated. So once I run this, you can see the data frame embeddings are now being stored in a data frame associated with the initial title. So before we had ID and text in our data frame columns, and now we have the associated vectors that have been generated using the Vertex AI embeddings model. So exciting. We just generated some embeddings. Yeah. However, these embeddings right now only exist in this data frame, right? We haven't actually done anything with them. We haven't put them into a vector database or anything like that. So we're sort of there. We're getting there, right? So the first step is being able to generate your embeddings themselves. I can see them. This looks good to me, right? So we're getting there. So, just to wrap your head around, how embeddings are organized and, from a vector perspective, different ways of, sort of calculating them. I think it's also important from just a general awareness perspective to know that there actually are different similarity calculations out there. So there's the L2 distance, cosine similarity, inner product. So it's very important, actually, especially when you're at the level of working with custom embeddings, to know which one you should be using. And this is dependent on how the embeddings model is trained. So if you're using the Vertex AI model, then we should be using, for example, in text embedding gecko, the inner product, or else if you're using the multimodal, it might be cosine similarity, right? So make sure you check the docs to make sure you're using the right one, because if you use a different distance calculation from what the model had been trained on, the that distance is going to make no sense, right? So it's very important. You're not going to get any results, or you might get lucky and get some results, but they won't be the most semantically relevant results, right? So this bit of code, just to sort of highlight that, it picks up one question randomly, right? one of the Stack Overflow ones, and then it uses the NumPy dot product function to calculate similarities between the question and other embeddings, basically, right? So print the similarities for the first 5 questions. So we can actually see the similarity, the number. So how similar are they? So this one, right, 0.49 is more similar to the original question that got picked than the next one, the 0.45. So that's less similar, right? And the most similar is probably this one at the end, the 0.5419. So the highest similar, yeah. And then, let's say you wanted to see, actually see what that means in terms of, because I think humans, we have a nice way of quickly validating and being like, oh, that makes no sense. Those aren't similar at all, right? And then print that list. So you could see here, this is the question, attribute and fine leaf, XML, lowercase attribute name. So the one that's most similar, it looks like, is itself. So that's good, right? 100% because it's the same. But then you can see a few of what were most calculated to be the most similar coming afterwards. So yeah. All right. So that was just to highlight sort of how similarity calculations are working, right? We haven't actually searched or retrieved anything yet because we haven't inserted our vectors into a database yet. So let's get into that. So we want to basically perform that approximate nearest neighbor, right, for search. So I'm not going to get into all the details of vector quantization. I think this has some nice notes about it, but the real idea here is that this scan algorithm is giving you a managed way to provide. It's balancing the performance of having it be super fast, but also the calculation intensity of trying to maintain accuracy, right? Because we don't want to just get random vectors back. We do want the ones that are the most similar, right? So, that's a balance between the scalability, is it super fast, but also is it still giving us the most relevant stuff without breaking the bank on running those calculations? Because, if you go through and you brute force the calculations, you could get the most, relevant or the most accurate by doing super intensive calculations, but it would be very expensive and very slow. So we need to balance that, right? The good news is that we have built these algorithms into our managed service of Vertex AI vector search. So it was previously known as matching engine. So sometimes if you're going through some of the documentation or other examples on some of our Vertex GitHub repos, you might see matching engine in there. We did recently change the name. So it's now known as Vertex AI vector search. And the idea is that you add your embeddings to the index, and then you issue a search query, right, with your own question or your own sort of embedding. So what are you searching against, right? So in this case, remember in this demo, I had to provide a search query. So, how to remove list elements in a for loop in Python. I'm providing this query, and then this is what's used to retrieve the most similar results back. So I have to give it this gets turned into its own embedding, and then these are the most similar embeddings that are returned for it. So yeah. And with vector search, the idea is that you can get the scalability, availability, and then also maintainability, because I think vectors and embeddings, what a lot of people also don't think about until maybe they've already developed quite a bit, is the maintenance behind it. Because you need to make sure that your vectors that are in that vector database are as relevant and as up to date as your data will be, because this is now going to be key influencer on the accuracy of the data that's returned and maybe given to a language model. So if you have a bunch of not old vectors in there that actually aren't relevant anymore, unless you have a process set up for managing, and updating vectors on an ongoing basis, and it could actually, you could be shooting yourself in the foot a little bit, because you're retrieving old information and then giving that to a language model, and it's not going to know that that's not relevant anymore because it's being told, hey, this is really helpful context. Make sure you use this, right? So you also should be thinking about not just sort of standing this up once and potentially proving that you could do it. But for a production application, you need a way to be able to manage them on an ongoing basis. So also vector search has managed capabilities for that, which is quite powerful. So in here, what we're going to do is we're going to save those embeddings that we generated. So if you remember before, in that data frame, we had the ID, the title, and the embedding, right? So we're just going to save a JSON file. So it's the first step with all of our embeddings. So we need to make sure that these are saved with JSON-L format. Definitely check the docs in terms of the input data format and structure, because if it does not meet the input data format and structure, you're not going to be able to insert them. So you might be like, so just check the docs, right? Export the ID and the embedding columns and then save it. So you can see right here, right? I'm going to show, these are the first few lines of our JSON, which has all of our embeddings and our vectors. You can see here, super human friendly, right? To read, but okay. So this is going to then need to be copied. So everything that I was doing before this was, I'll zoom in. Yes. Is that good? That seems a little too zoomed in, but okay. Maybe like this. Yeah. So
just open a notebook.
Here you can see we have this JSON, and now what we need to do is store this in a place so that it's not just living in my notebook. So in Google Cloud, cloud storage is where we store all of our sort of unstructured information. So in this case, this notebook has a nice sort of utility. What this is basically doing is it's making a bucket for you, and then it's copying the JSON into said bucket. So you can see it created this bucket, and then it's going to copy that JSON file into the bucket. So I now actually have a file sitting in a cloud storage bucket, not just this information in my little machine in my runtime environment, right? So it's been copied, it's now sitting in the bucket, but it's not in my vector database, right? So now we need to create that database. So we refer in vector search, we refer to the actual database that's going to store the vectors as an index, yeah? So you can see here, this is how we create the index. We're going to call the AI platform API. We need to give it a name. Make sure that we're using the right dimensionality. So 768 is, I would say, pretty common. That's probably what you'll be working with. And specify that distance measure type. So remember, because we're using a model that requires the dot product distance, this is what we specify. If you were working with vectors that did cosine similarity, you would specify cosine similarity. Yeah. And so you can see here the print down, it's going to create that index for you. And so depending on the size, it may take a few minutes to create that, but you can go and see and verify that it's created by going into Vertex. So on the left-hand side here, if you click and select vector search, this will take you to a view where you could actually see your vector databases, so your indexes, right? You might have created it in a different region, by the way. So make sure that you're on the region where you created it. And you can see that index here. So if this was still creating, that status would have a little swirly here, and it would say, creating, zoom in this way, it's a little bigger, so you can see it better. And then you could also see the vector count in it, because I already inserted the vectors because I went through this notebook, and then when it was last updated, right? So cool. We have created an index successfully. You'd also get an error message, by the way, if it didn't spin up properly. So like if there was a permission thing or something like that, you would get an error message with a description of the error. So the two types of ways that you could update the vectors that sit within an index. There are two types. So batch update, which is what we're going to use in this tutorial, and then streaming updates. So batch update, think about as anything that could be managed as a batch process. So maybe we update every week, or we update every day or something on a schedule, versus a streaming update has a requirement to update your vectors in real time. So obviously, definitely choose the one that makes more sense, right, for serving perspective. So if you have really dynamic changes to your embeddings and they do require real time, then streaming probably makes more sense. Otherwise, I would say if you don't have that requirement, just start with batch. So we need to then create that index endpoint and deploy the index. So to use the index, we need an endpoint. So the point of the endpoint is that this is what actually creates the backend that gives us that auto scaling capability, both to scale up as needed. So it's not going to fall over. So when we create the index endpoint, you can also go back into vector search, and you can go and make sure that it created correctly, right? So you can go in here, and because this has auto scaling capabilities, you could actually go in and make sure that you can monitor, for example, the node count, the shard count. You could look at the queries per second, CPU usage, things like that. So there is some sort of out of the box monitoring capabilities that you can investigate in. And obviously, I think depending on what your use case is, you may have different min or max replica counts from a scaling perspective. So if you just want to start small, you can just start with 1 and 1. So don't scale up. But obviously, this gives you the flexibility from an infrastructure perspective. So that way, let's say you start small, but then your application is growing and growing. You don't have everything that you've done here wouldn't be throwaway, right? Because you could actually just start scaling your stuff up more broadly, and it should be able to just scale up for that demand. So you can optimize for that, which is nice. Okay. So we have our deployed index ID. So that's the unique identifier that we gave it. And so you need to run that deployment. I ran this deployment code earlier, and it's giving me the error because it says you already deployed this onto here because I already deployed it when I was running it. So it's getting mad because it's saying, hey, this already exists, just so you know. So that says it's not going to redeploy it. It's going to say, by the way, you can't do that. Either you need to give it a new ID and deploy it again to that endpoint, or just use the existing one. So so you can't use the index until it has been deployed to the index endpoint. So you can't actually interact with it or run queries until it's sitting on the infrastructure behind the scenes. So then though, this is where it gets fun, and you can start to actually play with it and test it. So this is what I had talked about before, where we have to still provide a search query, right? So I have this test embedding. So my test embedding is just a question. It's just text, right? So how to read JSON with Python. And behind the scenes, what we do is we actually turn this into an embedding. So I'm just sending it a string, and this is automatically going to turn it into a vector. So this actually is just a vector. And to test the response, this is how I can test my semantic search, right? So I need to specify which index I'm going to use. I want to find the nearest neighbors on here, and then give me sort of, X number of similar responses. So I think in this case, I'm specifying give me 20, but I could also probably say give me 5 or something like that, right? So why would you change the number of neighbors that you see? That really depends on your use case. So in this example, right, it makes sense to include more because so you may want to actually look across all these, but sometimes, and especially in my experience, sort of building these systems for generative AI models, you might actually only want to limit it to the 3 most relevant results, because otherwise, the language model might get confused actually if you give it a bunch of different things, if it's all over the place. So that's part of the trial and error and testing and design considerations, which is really this parameter here, the number of neighbors and from a similarity perspective. So, we have now basically, just to recap, we read in some data from BigQuery. We read it into a pandas data frame. Yeah. Once it was in the pandas data frame, we called the embeddings API, the Vertex text embedding API. We generated the vectors and we added those to our data frame. We then took those vectors and we wrote those into a JSON-L file, which we then landed into a Google Cloud storage bucket. Once it was in the storage bucket, we parked those vectors, but we created an index, right? we used the batch update to upload that JSON-L with the vectors into the index. We created an index endpoint for the infrastructure behind the vector database. We gave it some specifications for auto-scaling capabilities, whatever. And then we're able to deploy that index to that index endpoint and then test to see if the search is actually working the way we expect it to work, right? So we can see from JSON-L to Python what actual results I'm getting from that sample data. So obviously we're only searching over 1,000 vectors because we just used the 1,000 rows from BigQuery, but this would be quite fast even if we were going over the 23 million rows. So yeah, so very important also is after you run this notebook, unless you want to keep this up and running yourself, definitely run the cleanup steps here. So this will delete the infrastructure and the resources so you won't incur any costs after you delete this. So just good to be aware that you will want to run that deletion. Yeah. So I'll come back to the rag stuff in a minute. I'm going to talk now about some images and image vectors, right? So we're going to go beyond just text. So we were just working with text before, but let's start to expand in terms of the number of modalities that we could use vector search over. So what's pretty powerful is that because these embeddings models have been trained on so many different types of data, is that they actually have an understanding of the semantic meaning, right, of what's in, let's say, an image or in a video. So, we might have millions of product images. So think, retailers or something like that, or product catalog, right? And so it's just not going to be sufficient to try to, potentially, or cost effective to try to generate a bunch of metadata across those images and then do a where statement on that metadata. That just might not be a viable solution, especially if we're just trying to find, let's say, where are the red, products with red dresses or something like that, right? Or images with red dresses. What if we just want to find that? So how can we start to use things like LLMs to understand the meaning and build these sort of smart search and recommendation systems? Or, and I've worked with a lot of teams who are currently building these types of systems. This is also pretty interesting for things like anomalies in product inspection images, factory security footage, right? Because it'll have an inherent understanding of what might actually be happening in those images. So this is now expanding from just text understanding of the data to image understanding, right? So we understand that the word cat, C-A-T, we understand that that's a cat, right? But we also have a model. That same model can see a picture of a cat, and it would put the vector representation of that picture of that cat next to the vector that represents the word C-A-T, cat, because it understands that semantically the meaning of those two things is actually the same. Yeah. So in this example, we have the ability to put in text and then search against, all of the images that may have already been embedded. So in this case, right, you can see I'm putting in a search query. So I'm just typing in something. Okay, let's do TV 55-inch 4K. Yeah. So you can see, right, that this is searching across 5.7 million items. So that means that there are 5.7 million vectors of images. And what it's doing is it's taking this text, so TV 55-inch 4K, and it's doing a vector similarity search, right? So which vectors are closest together of that text as a vector to all of those images as vectors in the embedding space. So I can see that this 65-inch 4K is very similar, the 50-inch TV model, blah, blah, blah. So it's picking up, right, on which types of images, and I didn't even search for a text, by the way. I didn't search with an image, I just searched with text, might be most similar. So this is not searching on the metadata or the product catalog or the data associated with it. it is simply checking against, the embedding that it has on that image, which is pretty, sorry, the product's sold out now. In a similar vein, you could also do, image to image, right? So let's do this dress. So I just basically am now saying, let me search using my image. So this gets turned into a vector, which probably has some representation against, like, looks kind of like flowery, right? Pattern type of dress, like short sleeve, it's got a collar. So that's all being taken into account in terms of the vector representation of that image. And then it's searching against, and it's retrieving all these results saying these seem to be the most similar from a similarity calculation to that dress. And it's pretty good, right? And it's obviously depends on what it has in the vector database to search against, right? So if it didn't have any dresses, right, I might not get good results. And that's just obviously a data thing. But yeah, same thing. We could take a look. Let's search with the car. Ah, that looks very similar, right? I think it is the same one. So it's just another image of that same car. So we can see it's picking up on which types of images would be most similar to this image itself. So I didn't even put any text in, but it understands how to turn that into a vector. So pretty nifty, right? The other interesting thing is, so this is showing a cups with dancing people example. And I think there's a, whatever. Oh, that's a good one. It's fine. So yeah, you get the idea, right? That you can go text to image, image to image. You could do image to text even. So it gives you the ability to start to flip between different modalities as you go through without any extra effort. So I think what's quite powerful about this is that, there's no prompt engineering necessarily being used. Everything's being grounded just in the actual data that you're providing it, and it's very, very fast. So we're searching over, almost 6 million images instant, and it's a pretty instant response. Millisecond, sub-second query time to give us back. So very, very powerful here. And how this is actually working is same idea. It's just now we are passing images to the API for the multimodal model. And then it's mapping those images and their meaning and then turning them into those vectors. So you can see, right, this one on food maps sort of to the food dimension versus this picture maps to this person, maps to the people axis from a dimension perspective. So same exact idea here. So if you think about it, really, a deep learning model could be designed, to be trained on pairs of images and text. So this is just an animation showing how these types of models are trained with the 3 submodels. So a model to obtain image embeddings, a text model to obtain text embeddings, and then a model to learn the relationship between them. So this is very analogous to adding vision capability to an LLM or a large language model, right? So now you can start to see we could have this shared embedding space for both words and then the images, they might be close together. So this might be an embedding, right, of this person. And then you might have an embedding for the word person with a beard. So these are going to be close together in the embedding space, right? Or a plate of food or a blue toy with clouds. These will have very similar vector representations because their meaning is effectively the same. So a really sort of innovative aspect of like recent vision language models is not just the capacity to search across images and text, but also the like librarian level language model intelligence in terms of organizing them for business use cases, meaning you don't have to really and I think this is probably true for a lot of Gen AI generally, but it's just like, you don't need, hundreds of thousands of examples from like a training or tuning data set. Or to have to train a custom model to be able to do some of this. It's now so accessible, and this used to be impossible with like image only deep learning models of the past. So it's pretty groundbreaking. And if you look at this example, so how do these vision language models perceive the world of images? So we have this multimodal embedding space of the Mercari item images. This is sort of a Google AI Viz demo to help you see and explore this space. But everything has been grouped into different categories. So they're zooming in on this one category here, and you can actually see, I think it's going to zoom in on, yeah, ceramic vintage, looks like basically like animals, and the carved wooden statues are close by up top. But you see how specific some of these categories are, right? And this gives you a pretty, I think this is a pretty good example of like the complex way that these models are actually understanding the images. And look how similar some of these are too, in terms of like what they're representing, or if someone was going to go buy something, you can see how this could be really powerful for like, here's a recommendation for another product that you might like based off of our visual understanding of what you've already been like browsing or looking through. So I think this is a pretty cool example of that level of intelligence. So this query, which is the cups in the Google logo colors on the multimodal embedding space, is going to give you these results. So it's now identifying the colors of the Google logo, right? So it has that inbuilt understanding of the Google logo colors just from the internet, right? Which of those images actually have those colors, and then bringing back what it thinks could be a good guess of those ones. You can see some of these are not as good, right? Like the Starbucks one is not, but this is pretty impressive, just in terms of the understanding of the colors that it would need to have. Yeah. And then like the other thing too is text in an image, right? So historically, to sort of extract text from images, has been more of an OCR problem, or maybe you have like documents where you have text in there and you want to abstract it out and do something with it. So these models, because we're now working in a world where text and image all come together, it's no issue, right, to actually read the text on the images without the need for any type of OCR. So if I say shirts that say it's my birthday, you can see it understands that we're not looking for a text embedding of it's my birthday. It's specifically now bringing back these images that have like birthday shirts for small cats or dogs or size small or something like that. So we don't need the OCR piece here. Just to give you some examples of where I'm seeing a lot of companies already using this. I think obvious one, we've seen a lot of sort of product data sets, but really sort of any e-commerce or marketplace app. So think, upload image of whatever item you want to sell. Then that service is going to search existing images for the same category or brand, colors or styles. And then maybe you want to use a language model on top of that to then generate suggestions for an item name. So seeing a lot of retailers or marketplaces use a combination of this type of tech. So this could reduce a lot of effort, right, to put an article or something on the market. And buyers can also, let's say, enter like a text query to find items to match your intent rather than, let's say, just the exact item name. Also, I think something else that's interesting is sort of the security monitoring space, thinking about like security camera images, or even just like footage coming off of factory line videos or things like that. So even with thousands of security cameras in the field and monitoring stuff coming in, you could probably watch for images that match text queries of like, just person trying to open the door, or the machine is on fire, which like sounds, I think, comical, but or the water is flooding into the factory. So like, let's say that was just a search query that you were just pinging every once in a while to just say, are there any results returned for this, right? Where there's like a fire. That's something that, or if you wanted to look back at your historical data, this could easily bring all that back. And you wouldn't need to train anything to actually look for what does a fire look like. It has a pretty good understanding of it, right? Or autonomous driving. So think about all the images and the videos that are being stored. So they're using those to train, right, vision recognition models. But it's also pretty critical to like organize and retrieve images quickly using things like query conditions. So let's say you wanted to bring back the data that has a crossing road with red lights on and pedestrians are standing, or a crushed car stopping in the middle of the freeway ahead. So let's say you need to retrieve that because it's really important for verification, right, in the model development process. So this is something where you could then just use a natural language question to then find relevant scenes across millions of images instantly, right? So you wouldn't need to tag them or label them. you can now bring them back, and that could really help produce improve productivity. Yeah. Cool. So I think that I haven't necessarily covered every service necessarily, so it felt good to just sort of flash up some of the different options from a GCP perspective. So just for reference, today the notebook that I had walked through was the Vertex AI vector search service. I will show you Vertex AI app builder search in a minute. Vision Warehouse is sort of part of the Vertex stack. So good for things like images and videos that are already indexed on Vision Warehouse, but you can't really export the embedding. So it's a bit more managed in that sense. So yeah, we'll show you the sort of search. I'll show you the search option in a minute. But yeah, just wanted to also go through these quickly. So there is an image search feature in the Vertex AI search website app. So this is, if your items are web pages or PDF files, Vertex search is going to be a good way to deploy and operate these types of capabilities because it's out of the box. It's fully managed. So we have, I would say, lower integration potentially and operation costs. And the downside is that because it's fully managed, it's sort of less customizable potentially, right? So you don't necessarily have as much flexibility in terms of the embeddings model that's being used, for example, right? So, but yeah, so just search. So Vertex AI Vision Warehouse is going to be really good for building a repository of multimodal assets, but this really only makes sense if you're working with tons of images and videos, video clips, so maybe video broadcasts or product images. So you can build your own warehouse using this tooling, which is an API first approach, so will require some coding and hands-on. And then, yeah. So next one here, multimodal embeddings and search. So you can also create your own custom search engine, which does have a bit of capability in terms of customizing, bringing some of your own embeddings if you want. So if you remember up until the point today, we had generated those embeddings and put them in storage. You could then bring them into Vertex AI search and conversation application and start to use them that way. So in the console Vertex AI search, if you search Vertex search and conversation up top, this will bring you to the product page. And so when we talk about Vertex search, what we're really referring to is when you go in and you create a search app, and then you can create a corresponding type of data store against it. So what you'll need to do is give it a name, select the region, and this is where you can start to create what we refer to as effectively sort of the data store behind it, but this is what do you want to search against. So if you are the domain owner of a website, you can verify your domain ownership and actually create an index on top of that URL. So you can't index websites that you don't have the domain, the URL support for it, right? So you'll have to do some domain verification there. But that could be a cool option. I've seen a lot of teams using this for could be good for like help FAQ websites, things like that. And then, so BigQuery, so import data from BigQuery. So there are a couple of different types of data sets from BigQuery that you can import. So structured, so this will be a BigQuery table with your own schema, which is structured data, right? So when we talk about structured versus unstructured, we're referring to, like the long strings versus it's just in a table, more like tabular data sets. You might have structured with metadata. So metadata being things like maybe the source, like the URL. So where did this come from, right? So maybe on Stack Overflow, for example, that metadata would be the actual link of the Stack Overflow question, right? So we don't necessarily turn that into an embedding, but we want to be able to reference it. And then unstructured, so we'll have metadata about the unstructured doc, so that you could have a tweet in a BigQuery row or something, and then maybe some metadata associated with it. So, and then cloud storage is pretty important. So in terms of just supports a lot of different types of docs. So the most common one that I see lots of teams testing out and seeing good results in terms of the power of search are the unstructured documents here. So you can see supported file formats. You might have data in PDFs, HTMLs, text, docx, PPTX. We also have some preview connectors. So we have preview connectors for things like Salesforce, Jira, and Confluence. So if that's something of interest to you, you please reach out to your Google Cloud team, and we can sort of help you get access for some of those preview connectors as well. But yeah, this is what's available right now. You can also work with JSON-L, and then this FAQs are for the Dialogflow chatbot applications that can sit on top of some of these search sources. So those are the main, and then also you could import manually by calling the API yourself. So this is to just give you a view of what we talk about when we talk about a more managed way of setting up embeddings using Vertex Search, because this, you don't have to specify the embeddings model. For example, you basically just give it access to the documents, and then it starts to, index them for you and start to create that vector store. But the downside is that it's not as flexible as taking the custom route and giving you full customization like what I had just shown to you today. So, it has a lot of functionality. So, I think best suited to depending on what you really like, what is your engineering approach and what's your use case. So if you do have the sort of engineering capabilities, I would say from a multimodal search and then reusing your embeddings. So something that I think a lot of teams don't realize when they get started with some of this in tech is that embeddings generation can also get expensive. So once you go through the pain of creating 10 million embeddings and storing them somewhere, you don't want to just be replicating that all over the place. So it's very useful to be able to port and reuse your embeddings, right? For example, so just something to think about as you think about your embedding generation and management strategy, right? And orchestration, sort of the full thing end to end, right? So the Macari example with the image demos I was showing earlier are using this approach. But yeah, this is the vector search capability, which will have more engineering and configuration needed behind the scenes, but can also give you that stream update if that's needed for real-time use cases. And then, also you need that sort of millisecond optimization as well. So we have quite a bit in terms of getting started. So we have some, resources here on the Google Cloud GitHub. If you're not familiar with the GitHub from a GenAI perspective, it's just, if you just search Google Cloud Platform and generative AI for GitHub, that will take you there and has tons of resources. So I've just talked about embeddings and vector search today, but there's quite a bit other. And if you go to this search folder as well, we actually have some sample notebooks for how to get started with Vertex AI search as well. So you can use the UI like what I was just showing, but you could also, sort of use some of the APIs as well. So this is the same repo. Once you've cloned this repo in, you'll also have access to this. So there's quite a bit that you could start experimenting with today. So, and then finally, I'm setting the stage for some of the upcoming RAG and retrieval augmented generation teams is coming. You might be thinking like, what does this look like when we start to use it, right, with our LLMs? And this is a good example, sort of RAG architecture, which will be coming. So this builds on top of what we just went through, right, which is that embeddings and that content index. So you can see here, we have our document. It goes in. We have our Vertex AI, text embeddings API. We have the embeddings, the content index, vector search here, right? So depending on where you want to store it for latency, key value store, fine for serving. And then this is where we get the semantic K matches that then get fed in based off of the user prompt. Those hit the language model, which then gives you a response. So you can see we've now augmented our base prompt with the results of the vector search, right? So when that query comes in, you convert the input prompt to an embedding, you call the index to fetch the top K most relevant matches, augment the prompt with the content of those matches, and then pass it back to the LLM. So this is sort of basic retrieval augmented generation architecture. hopefully you could see we basically have covered this top section, right? In terms of basically setting up your embeddings and making sure that they're ready to do things like RAG. But yeah.
Deb, that was fantastic. We've had so many comments coming in saying this was such a great session. Deb's
She
incredible.
has like my
So
favorite
thank you. I
session
will
so
leave you
far.
to catch
Oh,
your
nice.
breath for 2 minutes. Yes, we've got loads of questions for you, literally hundreds.
She
Big
was
shout
talking
out to the
fast,
moderators
but
at the
it
back
was
end as
okay
well,
for
who've been
me. I
frantically
thought
trying
she
to
was
answer all of
doing a
them while
great
Deb's been talking.
job.
Before we jump to those questions, I
How do I
wanted to
make it
very quickly,
code?
Deb referenced it as well, and hopefully this isn't the first time you're seeing it. We have a cloud program that has cloud credits, technical support, you name it, ready to support startups. So if you haven't already applied, please do. You can visit the link there or scan the QR code. And depending on where you are, if you're unfunded, if you're gearing up for your first funding round, if you're AI first, whatever it is, whatever stage you're at, we have support available for you. Also, you can use these credits, as Deb also referenced, to access all of the collabs that are being referenced, including the one today. So you don't need to pay for any of those. You can redeem using the cloud credits available to you through this program. So what are you waiting for? Scan that QR code.
Scan that QR code.
That's it.
They're
Before I
gonna do
bring Deb back
Q&A,
to the
so I want to
screen,
listen to Q&A. I know it's some good
have you had a glass of
questions.
water? Are you ready to come and answer some questions, Deb?
Yeah,
She
I
had
think
like
so.
30
Yeah.
seconds.
All good.
There she is.
Code.
Okay, great. I'm going to run through them. And just before I do, the RAG session is this time next week. Just flagging that for anyone watching that wants to come to that one. Okay, first question is quite basic, but I think important. What is the difference, the pros and cons of Google Colab versus the Vertex AI workbench?
Yeah, this is a really good question. So Colab is probably faster to get started with, but it will be definitely less customizable in terms of the basically the
The
back end
environments and
infrastructure
everything,
that
yeah.
is actually being used to run it. So is my screen still live? I can hop back in if you want to put my screen up. I can just sort of show you what I mean by that. Thank you. So, when we go to Colab Enterprise, you'll see things like runtimes, right? But we don't have all of the same types of runtimes in terms of the machine size and the resources that we can get access to. So the actual machine, right, that's being used to run it you won't have as much flexibility as we have in, let's say, Workbench. So Workbench, we have a much broader types of machines that are available. You can also you can't do this in Colab, but you can provide a custom container as the backend for a Vertex notebook, let's say. So if you have a ton of like custom environment dependencies that you just want installed to always just be there, let's say, definitely go with like the Vertex route. I'd say it gives you a lot more flexibility over the environment and the infrastructure to scale up or scale down as needed. Colab just won't give you as much, but for light touch, I just want to do some Python coding and I'm not going to do a ton. I don't need a GPU. I don't need to scale up or down. Colab might be far enough. So you could start with Colab. And then, maybe when you start to hit some of those limitations, you're like, it's taking forever. Like, why won't this run faster? That's when you might need to like juice things up and get a bigger machine. So the nice thing also though about the Workbench is that you can create them so they have all of the drivers already installed to also work with the GPUs. So there's actually some embeddings models, for example, like the BERT sentence transformer one, you can run that with GPUs. So you can speed up the embeddings generation process with that by running it on a GPU. So maybe you actually would want to use a Vertex notebook to get to that GPU so you could just hammer it out faster, right? So it's more of an infra, I would say, consideration.
Got it. Pros and cons. I like the way you said juice it up. That makes sense. That'll stick with me. Okay. KV asked, what are the considerations and challenges associated with selecting the right embedding model for a specific application?
Yeah. So honestly, that is a fantastic question because that the embeddings model that you use can have like a drastic impact on the quality of the results of what you're seeing. So the first one I would say is the modalities. So if you do think that you're going to be working with multimodal at any point, so text and images and videos, right, then you definitely want to, you're going to be limited, right? Because not all embeddings models are multimodal. Some are just text. So like some are just, the sentence transformer one I talked about. It can't handle images. So the first thing will always be dictated by the actual data that you think you're going to have as a starting point, because not all of them will even support all of that. I think also, this is probably getting a bit more in the weeds, but like the dimensionality, because higher dimensional embeddings can capture more nuance, but they could be harder to work with, and they could be more computationally demanding. So depending on your use case and like the level of dimensionality that you need, that might drive you to a different embedding model potentially. So there isn't really like a single best embedding model fits all, but I would say always start with, do we think we're going to have this type of data? Because if so, we can rule out, right? So, and also the other thing I would say is like, how much do you want to have to fiddle around with the custom infrastructure to do a custom open source model, right? Because now you're talking about running it and not just consuming it as an API, versus the Vertex ones, we host it for you. So you don't have to spin up a virtual machine or a GPU behind the scenes to run things on it. So it might just be easier to start with that one. And honestly, for a lot of these cases, the off the shelf, like sort of Vertex embeddings model for a lot of the teams that I work with is more than enough. So I would say probably start with that one because it's just easier.
We like that. Start easy, always.
Yeah.
Where you can.
Yeah.
Great. Jason has said, I want to make sure I'm understanding the flow correctly. So you take content that you want to create embeddings for, and you pass it to the embeddings API. At that point, it returns the vectors. So at that point, we need to store them somewhere, correct? Does it have to be a vector database, or can it be some sort of flat file index? Or can we simply keep them in memory if we only need them for a short time?
Yeah. I think you kind of answered your own question a little bit there.
She's like, yes, all of the
so basically
above.
you just need to store them somewhere in a way that has the similarity calculation built into it, so that it supports that distance calculation that you need, because that will be tied to the embeddings model that you chose to use. So you might have heard of like Chroma DB. So that's sort of a lightweight one that you can spin up like in memory. So for testing purposes, maybe just do something sort of lightweight. I see a lot of GenAI teams experimenting and just starting with Chroma and then like hitting a wall and being like, okay, like the ephemeral stuff is not working because I have to restart this every time and load them in from memory when a data set gets bigger and bigger. So no, you can definitely start small. And then, maybe that didn't work, throw that away quite easily and then start again. But then as you get up and you just scale more, then you probably want to move towards a proper vector database. But yeah, so you could just start with Chroma if it's pretty lightweight. But I would say save the embeddings in a solid, so save them in a BigQuery table or in cloud storage, because I mentioned this before. One of the biggest headaches I deal with teams is that they forget to save those embeddings. So they let the job run in memory for it takes like an hour and a half or something to generate them. And then their machine shuts off and then they lose all their embeddings and they're like, no. So just make sure you're also just writing out the core stuff somewhere so you can get to it again.
Yeah, super good advice. We've all been caught short with that before, haven't we?
Yeah, too. So yeah.
Happens to us all, right? Ram Kumar said, do we have an example notebook where queries involve combining structured marketing analytics data, like Google Ads, with unstructured product information, i.e. description and reviews? The goal here is to use LLMs for anomaly detection in a combined data set.
Yeah, so there's a pretty good one where I think we have an example under search where we have this custom embeddings notebook. So I would say this is probably a pretty good reference where basically we have, so we're scraping some of the HTML from the question pages. This is that Stack Overflow data set again, but we have structured metadata, which I'm assuming would be your sort of things like creation date, answer count, question URL, body, and title, along with the actual embedding, which would be the product description and the product review probably. So these get combined into effectively like the same row, and then you can use those. So that's a custom embedding approach with structured metadata effectively. So I would check out this notebook as a good example to follow. Yeah,
Great.
this one. Yeah.
Custom embeddings with Vertex AI Search. Great.
Yep.
Okay, last question. You ready?
Yes.
Is there, yes. Is there a good
Yes.
workflow inside of Vertex to clean the HTML pages and put them in the proper structure to facilitate embedding?
Yeah, so now this is a really good one. I think so. When I think about like sensor readings, like things like temperature, humidity, pressure, you could represent those as like continuous numerical vectors. So like track changes, identify anomalies, and search patterns like across sensors. I also think things like vibration data. So, embeddings could capture subtle differences in vibration patterns in like predictive maintenance use cases. So try to detect imminent equipment failure by then searching for vibration embeddings similar
Mm.
to known failure patterns. Or I was reading about something else. I think it was like location data, like GPS. So if you embedded locations for
Literally
things like
massaging the
geofencing
ideas out of
or
her
proximity
mind.
detection or movement analysis, that could be an interesting one. Obviously, security cameras. So store the image embeddings for fast object detection. So, suspicious activity or accidents that fight the fire, flooding, things like that, or even just industrial inspection on those things. I haven't seen as much, but I think audio signals could be interesting. So, like, if you embedded audio patterns for faulty components or unusual sounds for like a maintenance issue or something, or voice commands could also be one. I was like maybe smart devices or like natural language interaction. So those are just some I think that because vector databases can handle such like diverse data sets in terms of data types, so sensor readings, images, audio, whatever. I think it could really simplify because it's really good for turning that super high dimensional data, right? Like raw sensor readings or images into those lower dimensional representations. So obviously good to have a like solid use case in terms of this is what we want to see if we can search to get to detect some of these things. But it could be very interesting, right? Hopefully that helps.
Got it. Sounds very interesting to me for sure. Okay, Deb, I'm going to leave you to get on with your evening. Thank you so much for joining us. What a brilliant session. See you soon.
Thanks so much, everyone. Thank you.
That was
Bye.
so good. Oh my
Okay,
goodness.
all that's left for me to say is thank you for joining us. I hope you enjoyed that session. I feel energized and very like I've learned a lot. Our next session is on Thursday at the same time, and we will be covering code generation, completion, and chat. So you don't want to miss that one.
That's going to be
That's all
fun
from
too.
me. Have a lovely rest of your day, evening, wherever you are, and I will see you in class very soon. Take care.
Okay. This series is getting better and better and better. Um my favorite two sessions so far have definitely been what's her name? Deb was really good. I liked everything she was talking about. Also, I was very interested in this topic in particular, so I guess that definitely helps out, but she gave like a really good overview to me. Um she said it was like the orientation. I thought her orientation was like a good overview of embeddings versus the vector database and like the whole point of it. So, just basically like the concept of taking existing data that we already have, giving it vector representations, and then because if you don't have any familiarity with like how machine learning works, I mean it's math under the hood. So, um matrix math, which the smaller component of a matrix for like a particular piece of data is like a vector. So if you think about like vectors like actual arrows, like three-dimensional vectors, it's a little bit more limited, but when you think about like a really large vector, it can have however many dimensions, then you can kind of imagine how the matrix math and vectors kind of works together. So that makes sense to me once she broke it down like that. I'm like, oh, okay, duh, right. So now I'm very curious about. I think I'm gonna like let my brain stew on some ideas. But of course they have some good stuff to start with as far as like just general examples, and this is the this is the notebook she was going through today, which is a part of the Google Google Cloud Generative AI repo. And then she had mentioned that Scan is open source. Oh, that was the other thing. I I would have thought that we would have to do our own embeddings or yeah, I would have thought we had to do our own embeddings, but Google has of course, they have an API for everything, literally. They have a model for embeddings. So you can take all types of different data and you can actually create the embeddings using Google tools as well. So that's awesome. Like it's really basically if you have a use case, you kind of know exactly what you're trying to do and you already have your data, then pretty much Google Cloud probably has something for you. I think that was the gist of it, but yeah, that was also a big standout to me. I'm like, "Oh, that's awesome," because that would have been my next thing. It's like, "Oh, okay, so now I got to learn how to do embeddings." Which I mean, I guess eventually I have to learn how to do anyways, but like if I just want to build something, that's a heavy lift, but or could be, but apparently it's not because they have those let me see if I can go into I'm going to go into before I get off of the stream today, I want to go into the console and see the model garden. Where is it? Oh, here it is. So this is model garden. Um, here's embeddings, just right up top, just being like, hey, come see us. These are embeddings for text though, but like she said, there was here. Let me search for embeddings because I see blip image embedding embeddings. Oh gosh. Oh, they have text classifier. Okay. So task. Can I can I search by that? I want to search by this little tag right here. There's only two. Oh, I guess there's only two main options, which is what I do remember her talking about these two mainly. So embeddings for multimodal. So if you do know you want multimodal, then you should just use this one. But then the other one here is embeddings for text. So I think that'll be something I really want to try out. Um, I'll stick with the example that they have in Colab. So tomorrow's Wednesday. I do have some work to do for this app that is because we have to get ready for beta on Friday. I think we're opening or Thursday. So I will probably be doing some work. But as far as stream tomorrow, what I might end up doing, I might end up just working through the notebook for. I want to finish my other notebook. Hold on, where the heck is it? I want to finish the notebook that I was working through, which was about chain of thought method and React method for prompt engineering, and then I want to work through this notebook as well, the vector search notebook. I feel like I can get a lot out of this. Then I could get a little bit more ideas of maybe like a small project that I could adopt and try to deploy and see how it works. But I really, really, really highly recommend the material that they have going for this. If you are interested in like practical generative AI applications, business applications, got a startup idea, whatever the case may be. Oh gosh, now I have to think about how, yeah, I have to think of, I wonder, okay, I'm gonna be doing some research because I'm wondering what's the like what's quote unquote large dimensionality for the vectors? Like what's the best, like cuz if you talk about like social posts or something like that, a tweet is a tweet is only going to be so long. But I would want to see actual individual data records could be for but still be efficient in being able to be categorized. Hmm. But then you're combining it with an LLM. So, anyways, but yeah, I highly recommend this. So this is you can go to cloudonair.withgoogle.com, and then if you do go here, you go to events. You should be able to find an event. Let me see. Is it gonna come up under on demand or it might not be that easy to distinguish actually because they go session by session. But anyways, the most direct link is cloudonair.withgoogle.com. Then it's /events /startup school AI. So I'll share the link, and I think we always have those in Discord too. So feel free to join us. Um Tomorrow I'll be back. I literally stream every single day, y'all. So you can always come and find me if you want to come back and chat. I have to do a lot more of the like studying and just focusing on the AI material, since that is just strongly I want that to be like my main focus. But in the meantime, I think a good rate for tonight would be for Pranay. He is actually working in AI as well, with OpenAI. So if you want to kind of keep this something going in a similar vein, I think that's a good rate for us tonight, y'all. And I appreciate everybody for hanging in there. I just really wanted to get this done, and I'm glad I did it. I'm glad I waited and gave myself some time today because I was able to like actually have some enthusiasm and excitement around the material. But in the meantime, let's go ahead and have our raid, and I will see y'all tomorrow.